Okay, so the best day for monitoring, that's always pretty interesting. Reducing costs without increasing emissions. That talks about some of the new technologies out there. Predictive analytics is one of the things I've specialized in over the last 5 or 6 years. Controlling the heat, Aaron's probably going to talk more about that because he does a lot of our audit support now. Then Appendix K, Quad O, B, and C. I know there's not a whole lot of NGL stuff. Does anybody do NGL right now? We have one Targa. So Targa might be interested. The Appendix K, everybody should be interested because that's kind of what everything's going to, it's going to be the new Method 21 for camera work. But there's a lot of ridiculousness about some of these new rules, and we'll kind of talk about this also. So let's talk a little bit about variable quality. Pretty much in any type of industry where you have a hands-on type of work, and I'm talking about like the LDAR technischen. Not every, I know it's almost painful for me to admit this, but not every Method 21 is of equal quality. You have, there's a lot of fine, the probe has to be right on the leak interface. You may get different readings and you have to be able to go back. You also have environmental factors at play as well, the wind and such. We'll kind of move into that a little bit. Over the years, since the Industrial Revolution, everybody's always been trying to figure out how to eliminate this variable quality and make everything 100% perfect. They did a lot of this with when the robots, the automation, when that came along. But LDAR is kind of a perfect study because you really have a good metric for LDAR for determining quality. And that's the leak rates. You can always tell the leak rates. You should have over a year's period, you should have an equal leak rate, throughout the day. And also, different days of the week should have equal leak rates. So the two main factors are the atmospheric conditions and then temporal factors. I could just mention time of day, day of week. So we're basically going to talk about the two main things. How does wind affect, and how does the day of week or the time of day? And to me, from my background as I studied industrial engineering, it's super fascinating for me to be able to say, when you're tired and groggy in the morning, your monitoring is not going to be as good as it is after you've had a few cups of coffee. Monday, it's not good for anybody, including technicians. Neither is Friday. But as we just mentioned, there's a precision, a hand element to Method 21. And I've always, tried to elevate the technician. A really good technician, somebody who's actually talented, ought to be able to go a little bit faster than somebody who's either brand new or not very good at it. Similar to like video games, certain people just have a knack for it. Technicians are no different. There are certain technicians that they're just leak finding machines. It would be great if we could, recognize who those people are and maybe either allow them to go a little bit faster or maybe even pay them a little bit more money.
Which, as Andrew's saying, monitoring is kind of the norm, right? Everybody can go and put their probe around it accurately and do it, but it takes a little bit of it takes experience, recognition to be able to tell the difference. They jumping around 1 part per million, whether are you getting the reading or is that natural? That's something that individual technicians, when they're monitoring, gain through experience or just sheer ability where they catch on a lot quicker.
Yeah. So we'll start, with the atmospheric conditions. Obviously rain is an issue because you can't sit there and monitor, and especially if you're in East Texas where it rains, almost every day in May and June, and it's really, it's not that because you can't monitor, it's because the schedule gets compressed. You're expected to get a whole month's worth of monitoring done in 10 days, and that's where it becomes an issue, is because they're having to monitor a lot more components. So of course the quality of the monitoring reduces during that time. you know, dark, dimly lit conditions, that kind of speaks for itself. The temperature thing, I'll mention that whenever I wrote this 5 years ago, I had a limited data set on the temperature thing. In the 5 years I've been with the MSI, I've managed to travel a little bit to up north, you know, Pennsylvania, you know, done a lot of work in Illinois and Indiana, where, you know, I've seen what, you know, 15-degree weather can do to monitoring. I actually was in, I helped out, you know, trying to be the leader that I am. You know, it was like, hey, I'll get some monitoring done. I'll help you guys. Just, you know, just have the machine calibrated for me because I've been out of it too long. So anyway, they provided me with a calibrated machine, and I went out there and did some monitoring. You know, by my own metric, I failed. I mean, apparently I'm not as good as I thought I was, but of course, you know, I'll lead it back to saying, okay, we were in a propane unit. It was 15 degrees. There wasn't as much pressure in the lines, maybe, I don't know, but really was the wind and probably standing in 6 inches of snow, you know, kind of put a hamper on the monitoring. So the temperature, I'd like to kind of walk that back, and I'd say the temperature, especially in where around the bullet tanks, when those bullet tanks get cold and frozen in 15, 20 degrees, the pressure underneath those bullet tanks, it goes from, like in normal conditions, around 80 degrees, it's probably around 140 pounds, 90 degrees, maybe 150 or something like that. When I did my study, that's about where I compared it against 80 to 90 degrees, and I didn't really see any difference in the leak rates. What I need is probably data from up north where it swings from like 15 degrees, see the monitoring at that point, and then compare that to 90 degrees. So the whole temperature thing, I kind of would like to walk that back a little bit, especially maybe not so much for the process units because that's all temperature and pressure controlled, but where you have the storage facilities, that's, you know, sometimes that's affected by the pressure. Wind is always an issue. Wind is a problem no matter how you look at it. It dilutes your sample, and I've done a number of studies. Here's that tank form data. So yeah, I compared like 84 degrees to 9 degrees. I'm going to redo that. I'm going to get some data from up north. But for small variations in temperature, I can say it does not make a difference. You know, based on this particular study, I will redo all that. So the typical wind pattern, I always like to point this out. I know everybody's used to looking at, you know, probably this particular graph even. You see it, you know, starting out in the morning, the wind is usually pretty calm. It builds up throughout the day, usually hits the top of the day, you know, following the highest temperature of the day, usually around 4 or 5 p.m. So the sun peaks at noon, the temperature follows up by a couple hours, around 2 or 3, the temperature peaks, and then the wind peaks after the temperature, usually around 4 or 5. But yeah, so the typical wind pattern is going to have this oscillating curve to it. You might know where I'm going with this. But anyway, I did a few different research methods. I did like an indirect and a direct. The indirect is I downloaded a lot of data from, I think I used a GBR data. So it was really close to I mean, it's a huge refinery down on the Gulf Coast, if you're not familiar with it. Lot of data points. I was able to compare it to an airport wind data that was, you know, less than 5 miles away. And that was, then I did more of a direct method, which quasi-scientific, I'll say. That was basically, we have some training equipment. It's kind of like a big loop that we could pressure up with propane, and we can actually have technicians go in there and find leaks on this equipment. I was able to, you know, pressure it up, and I used like, I want to say it was like 2 box fans to kind of simulate different mile per hour winds, and just to see what the different things were. So this talks about the indirect method. We just kind of covered that a little bit. So the exposed in the tank farm area, And again, this is like, just real data throughout, 1 year is several thousand data points. So it was actually pretty good. And 0 to 5 mile an hour winds, we had like a 3% leak rate. And this is, 5 mile an hour, that's usually what you get in the morning. Then later on in the afternoon, the wind goes up, but in the areas where I could say it was 10 to 15 mile an hour winds, the leak rate was more closer to around 1% or less. So whenever you guys get audited, these auditors show up on days where there's no wind, and maybe you should be a little bit worried because they're likely to find a lot more leaks on those particular days, especially in the exposed areas. The sheltered areas and like within the process units, not near as dramatic, but there you can still see some. The thing about the process units, those towers are generally in process units, and so the size of these towers, when you're doing your LDAR monitoring on them, I don't know if any of you climbed up towers. I've done a few in my day, and on say a 15, 20 mile an hour day, the size of the towers, you have this Venturi effect or something, and that wind accelerates around the towers, and maybe 15, 20, but on the towers, especially because it's elevated, it's more like 30 to 40 mile an hour winds.
And if I can add something, one of the key reasons why this data, what we've seen actually collecting this, has made it beneficial, is it allowed us to actually kind of schedule it around, right? You can't ever completely avoid checking for leaks and doing LDAR out in the field. You're going to be in these conditions. If you're waiting for the perfect day, you will never be able to finish your entire facility's inspection requirement. But knowing this allows us to be able to prioritize, tank farm areas, in the morning, high wind areas, your columns, do that stuff in the morning, and then do the more sheltered areas, how Andrew's talking about later on in the evening. That way, everything does kind of average out toward the end, but we can prioritize those areas. So how he was talking about, if an auditor's coming out and he's there on that ideal day, and it just happens to be there, where he would typically find a little bit more than what he finds average weather conditions out. By doing that and prioritizing those days, you kind of closely map those conditions a lot. Right? You can never make it where everything is ideal. I mean, no matter what part of the country you live in, you're going to either see wind, extreme cold, rain, always going to be something that affects it. But knowing that information to be able to prioritize and minimize the effects of it, it's really been the key benefit that we've seen from all the studies that Andrew put.
Yeah, so whenever we give our supervisors and such training on this, we usually encourage them to tell the technicians that if they have routes that include towers, do those in the morning. For one thing, you're not as fatigued. You're more likely to actually climb and do all the components on the tower. The other thing is you're not as affected by the wind. So it's better to do those early. Here's that direct testing method, and you can see over there on the left, that's kind of the little trailer we have that has like a little loop that we're able to charge up with propane. And you can see we kind of just positioned on an open-ended line, just like you would be monitoring how you would monitor say a carbon can, opening right in the middle. So we positioned it, and then we used, like I said, a couple of box fans to simulate different winds. I was able to get up to 7 miles an hour with these box fans on full blast. But you can see the readings. We adjusted it, the reading to be at 500, just above the normal leak definition. But as we turned the fans up, the reading actually went down well below 100. So as you can imagine, all these carbon cans that people are monitoring in windy conditions, they're not breaking through that day because it was a little bit windier, but the next time they monitor it, it's calm, all of a sudden it breaks through, and this is why. And while he was talking about different strategies to take this knowledge into account, you monitor different areas based on known wind patterns. One thing comes to mind are these big spheres a lot of people have at their facilities. You know, if you ever stand in the bottom of these spheres, you're getting a lot of times 40, 50 mile an hour winds at the very base. You know, especially those areas, you know, you need to hit those early in the morning before the wind really picks up, because that wind just amplifies. Wind blocking techniques. I know we've all seen auditors go out there and you know, kind of, you know, put their hand around, or they'll use their little clipboard and try to block the wind. Like, that's not method 21. They're like, yeah, it is. You know, so a lot of times, you know, a lot of times, all the time, I always tell the technicians, if you have the opportunity to get around, put your back to the wind, put the component in front of you and monitor the component, you know, block as much of the wind as you can, because that's exactly what the auditors are going to do. And the whole idea is that, you know, we want to match or exceed the leak rate that the auditor brings. And we talked about all these pretty much understanding the morning versus the afternoon. Encourage technicians to monitor towers in the morning. So here's my little robot guy that I came up with 5 years ago with a pencil. So you know, you talk to some of the auditors. You know, I don't want to name any names, although I really want to name the names, but I can't. Anyway, yeah, they're like, I mean, this was all new to them. It's like, you mean that monitoring on a Monday, if they're implementing method 21, that could be different. You know, like, yeah, and there was a lot of, when I first introduced this concept, I mean, a lot of people just, you know, it just blew their minds that you know, not all monitoring is exactly the same.
Not really a unique thing to LDAR. Right? Any production-based job or human effort job, right? You see the same kind of trend in any work where an individual is doing, whether it's LDAR monitoring, filing reports, people delivering packages, any time that a human, you know, it's involved where the human's productivity being done, or that their accuracy. Who here can say that Monday morning when they show up for work, they're doing the same, you know, they have that same attention on Wednesday afternoon? And the same thing goes Friday afternoon, last couple hours of the day. I don't think anybody's 100% focused like they were in the middle of the week. They're thinking about, hey, what am I going to do? What am I going to do tonight? What's planned tomorrow? Me and the family going to the beach or something Saturday, or going to go see a movie. So it is something that, you know, not surprising to see when you review the data, and the data does kind of show that you get different activities during those time frames. And it falls kind of the same way any office job, construction job. You just get the productivities when it's the human-based error. It is a variable range that kind of evens out throughout the week, but you see the same thing. Even when auditors come out there and do it, you'll notice the auditors, when they're first starting, they're usually not finding the same amount that they end up finding through their techniques change, because anytime you're just starting something, you just don't have that same mental focus that you did do about midway through. And then you also see it drop off toward the end of that time frame. Mental focus is there. And when you're looking for small leaks, and it's so important to maintain that proper probe placement and stay on a component for a certain amount of time, that little bit from having the 90-degree angle to now you have a 75-degree angle, 80-degree angle. You start missing a few things here or there, or not really missing, but not getting that maximum intent of all leaks.
Yeah, so I'm sure it surprises everybody to hear that of all the days of the week, Monday is the highest of all the absenteeism in any industry. But yeah, everything he said is, yeah, I'm never going to read everything word for word because that'll just bore the hell out of everybody. We're going to sit there and talk, and if y'all, hopefully y'all can see and read, and y'all can have copies of those slides. But yeah, everything you just said was everything that was on these slides. So
Sorry, I jumped ahead a little bit.
yeah, this guy has like anybody know who Sheldon Cooper is? Everybody? Yeah, idyllic memory. Um, no.
Oh, no, anytime you have a question, feel free.
Yeah.
So we have a couple tools that we use, which will actually, they're actually a little bit further in the presentation when Andrew's, we're going to get into a section about predictive analytics and where we actually take all this data that we have, basically create tools, identify these issues, and we have some key examples where we can actually show it, and I can bring up, some implementations, how we implement. We could go into some pretty good detail on that a little bit later on. But if you have any other question about any specific part, feel free to hit any point. Yes, there are several ways that we can what's called, and ways where you could track it to see where you need to address it more.
Yeah. And a lot of times it's knowing that there's a difference, that there is a variation in the quality. You can, a lot of times you can talk with your people, your supervisors, you can give them this specific training saying, hey, we know that, Mondays isn't usually that great. So maybe do something, with a lot of people have these tailgate meetings on Monday mornings, just to give them a little bit more encouragement. And sometimes that helps even out the variation. One thing he did mention is the less supervision on Fridays. A lot of times that's also a major factor. Technicians need supervision, and the lack of supervision. We'll see that here in a second. So here are the days of the week, 1 through 5, Monday through Friday. The vertical bars is the number of components monitored. Obviously, Monday and Fridays are going to be less because you have fewer people. The leak percent shouldn't. Method 21 was equal. That leak percent would be straight all the way across. Now, of course, some places, Thursday, Fridays, you're doing rechecks and things like that. So it could actually increase your leak percent because rechecks are, they fail more often than normal monitoring. So anyhow, this is a pretty typical pattern for the little line with the little triangles. Leak percent a little bit lower on Monday, then peaks out Tuesday, Wednesday, then Thursday, Friday starts kind of taking a dive.
Yeah, which, if you can stay here for just a second, one thing, when we are going through the data, the biggest thing that we see is, as you see, Monday is your least productive day, but as you go along, Friday, you'll get that set, you get production, but your accuracy starts tailing off. That's where you got to try to minimize both on both ends. Mondays, you're more focused on a production standpoint, up with that. Whereas Friday, everybody's just rushing through it a little bit, so they're still being productive, because you see that rush to finish up the day, start your weekend. That's where you see a slight curtail in your accuracy, where you focus more on narratives for those days to make sure you do.
And that is if you do work on Fridays. Some places they just don't work Fridays, but this is I don't know if you can read that far right side. That's we're looking at hundreds of thousands, 400. So during this particular year, on Wednesday they monitored 400,000 components. So it was a pretty big sample size. Here's another one I kind of talked about a little bit on Thursday. They have a little bit of a spike in leak rate, and that's normally because they did rechecks. These are 4 different sites. I'm going to kind of walk through real quick. And they're all pretty big. This one was like that Tuesday they monitored over 500,000 monitoring events. So that's a pretty big sample size. Here's one site where, yeah, Monday you had a low leak rate and it kind of built up through Wednesday, Thursday, but it didn't actually drop on Friday. And I think it was also because Fridays they were doing a lot of rechecks. And this next site, this prompted us to make a change on what we were doing at this site. We saw the leak rate on Friday drop off. And a lot of times on Fridays, people were just coming in to pick up extra hours that they may have missed because they were absent or something during the week. There wasn't any supervision on Friday. This was normally a Monday to Thursday facility. And so as you can imagine, when we saw this, little statistic, we said, okay, no more monitoring on Friday, unless we have supervision. But supervision makes a huge difference. I think they were just kind of showing up thinking they could just have an easy afternoon, easy day. Yeah, no environmental factors for the day of the week. It all kind of averages itself out. Potential strategies to reduce. I mentioned the Monday tailgate meetings to include discussions on quality as well as safety, awareness training on fatigue. The whole idea is to get your technicians to help kind of self-correct on what they're doing. And then, perhaps some kind of incentives, to get people to actually, make sure they always show up on Mondays instead of like doing like attendance throughout the week. Let's just look at, focus on Monday because that's where the issue is. Usually if they miss like a Tuesday or Wednesday, there's a good reason. Monday is usually not a good reason. It's probably because you're mourning the Dallas Cowboys or something. Yeah, so here are some other studies I mentioned throughout the years. I mean, you can look through the internets and there's a lot of stuff out there for it. Not just LDAR. I don't want anybody to come out here thinking that this is only an LDAR. I know I have the same issue on Monday. I'm especially since COVID. Everybody's been officing at home or has had a taste of officing at home. We all know that Monday we're not. We like to think we're always as productive, but we know we don't get as many emails out on Monday as we do Tuesday, Wednesday. I mean, there's ways you can kind of track yourself, and you're not getting as many emails in either. I mean, you're just not. Nobody's communicating, nobody's making calls. All of a sudden, Tuesday, Wednesday, the phones start to come alive. You start hearing from everybody. So it's across all industries. Okay, so now we're going to talk a little bit about the time of day. Again, this is across all industries. I mean, you guys can imagine back in the day when people used to hand assemble vehicles. Our dads always had a saying that they must have, this car was assembled on a Friday or something because it was always breaking down. The same is true during the day. Again, I'm not going to bore you with reading these slides, but there are a lot of studies, especially around the time of the Industrial Revolution.
And really the key with just like the days of the week, it's really just whoever's doing the monitoring, one of those starting the morning off right. A lot of the most successful programs that we've seen, all those programs start off with some sort of a kickoff meeting. And the main purpose of that meeting isn't, if there's mass amounts of information changing. It's really just getting people kind of focused on work and, more aware and just awake and ready to work. And that's one of those things in the morning. It's the key factor. And then the end of the day, where we see, a drop just kind of like we do on Friday. It's just one of those touching base with people. We've seen people just call over the radio just to touch base, see how people are doing, see where they're at, just a quick little check-in. And that's just, you've seen massive improvements just by doing those few minor things, by, getting people started the right way. And then at the end of the day, it's really more about keeping focus. And that's where you see the biggest, improvement. Still, nothing that ever have solved 100%. There's no way to change the fact that not most people are not morning people, so they're not looking to break work at 6 a.m. And at the end of the day, everybody's looking forward to get home to their families, or go out to eat, whatever they, go have a drink somewhere, whatever they do once they clock out at the end. So it's all about getting started the right way and keep focus on the key things, and translates into the accuracy and productivity of your monitoring, along with even those that aren't doing monitoring, that are doing additional jobs like MOCs, and that you see that same productivity and same accuracy there.
Yeah. So again, I have 4 of these to get through real quick. And by the way, we have like I said, 3.5, 4 modules. We'll take a short break in between every one. I'm old. I need these breaks. So yeah, 7 to 8 a.m. there was a 3% leak rate. Then it actually spiked up to over 3.5%. Again, the line represents the leak rate. The bars represent how many actually got monitored. In a perfect world, the leak rate, if everybody's doing the same method 21 throughout the day, it would be straight across. Here we can see that it peaks at usually around 8 or 9, then it drops off throughout the day. Here's almost an exact straight line drop off. But also, remember we were talking about the wind patterns. Throughout the day, there's the wind builds, and also the leak rates drop as the wind builds throughout the days. But in every case, it's usually about the same pattern, except for here, for some reason, people at this site, they get out there and they start monitoring. Maybe they didn't get anything done before 8, I don't know. But this was the only anomaly for that.
And if you go back to that anomaly is really just because that's one of the places that we saw the good start of the day meeting, how they started their day. They didn't really have anything for the end of the day, but could clearly see, and when you see what they did, they had that morning meeting, getting everybody involved, ready to work.
And another one. Now I would mention the 10 a.m. There was generally a spike in production around 10 a.m. That's usually because people are trying to get their routes done before lunch. So they had a thing where they wanted to get so many done before they broke for lunch. It didn't include the monitoring that got done between around 11 or 12 because it wouldn't have made sense. But yeah, there's usually a pretty good spike around 10 a.m. So yeah, there's a reorientation first thing in the morning. And of course, quality and productivity decline throughout the day due to physical mental fatigue, and then also wind patterns. I just mentioned a lot of times they push real hard, but yeah, a big part of it is at midday. Whenever it starts getting hot, your mental acuity decreases. It's hard to be as good whenever you're uncomfortable as whenever you're a lot more comfortable when you're fresh in the morning. I'm not sure why I bolded environmental factor, but anyway, wind is definitely the biggest environmental factor that affects monitoring quality. And that is certainly true with every one of those slides. As the wind increases throughout the day, the amount that the number of leaks decrease. So what are the things? Again, we teach mental and physical fatigue awareness. So, hopefully the technicians can self-correct some. Health and wellness programs is a good idea. Dietary choices. Back when Brian Whitley was, does anybody know Brian Whitley? Okay. big guy. I used to mess with him about the dietary choices. But can't really mess with him. Well, yeah, I can. Too much Diet Coke. Good ergonomics. Having good backpacks is kind of a big deal. And also the wind strategies and blocking, I mean, all that. And also we always have to remind our technicians, because the technicians will, you know, kind of reinforce this amongst themselves. They'll tell each other that there are quotas, because anything they don't monitor, I'm going to have to monitor. You know, if you don't get, you know, your 500 or 400 done, that means I'm going to have to pick up his slack. So the technicians, there's a lot of peer pressure amongst the technicians to get a certain number, so that everybody's pulling the same load. So we always have to remind them, hey, that's not right. You know, you have, everybody has, you know. So this kind of leads us into our next module. So if y'all want to take like a 5-minute break or 10-minute break, and we'll start back.
In the next section, we're going to kind of talk about the different technologies and stuff and the different things that we do, which it does involve how we kind of mitigate all of those issues. The lead section will brought up a lot of issues, why stuff, you know, stuff not this. We'll be going into quite a bit about what we do with that from happening, catch it when it does. If anybody ever says they will 1% prevent it from ever happening, I'll tell you that's going to be all humans, everybody's. So it's more about identifying the issues and then correcting them, or making sure you get accurate data when you find it. Which 5-minute break.
Yeah. Okay. Yeah, 5 minutes.
Okay. Yeah, well, nobody wants to hear us talk straight for 4 hours.
Oh.
Oh, and everybody, there is a sign-in sheet up here, so if y'all do want to sign in, I know a lot of people use this for their annual certification and trainings. That way y'all, we can make sure y'all get a record of that. And there are cards and things up here as well too, if anybody.
Also, everybody here is invited to our rooftop tomorrow night.
The ability to give a copy of the slide?
Yes.
Yes.
Should I put my email address?
Yes, if you add your email address, if you want to call a copy of the presentation and slides, if you got your email address at the end of the training.
So we currently use you guys, so I just wanted to say, Louis and I am.
Okay.
Is our lead, and then Jacob Ayers is also works for us, right?
I actually was talking to Jacob last week.
Oh, okay.
I talked to Louis almost every other day.
Well, I appreciate working with both of them, so.
Oh, good.
That is, it's always great to hear positive feedback.
I've been working with Louis, I was talking to them yesterday, so Louis is like on his fourth with this company that.
Yeah, because he was Summit, and was it with Summit or?
He was with Bureau Veritas, Summit, and with Permanite.
Okay, so he was permanent. Okay, so y'all were with him before he went to Summit.
Yep.
And y'all switched over when Summit, and then Summit was bought by Bureau
Bureau
Veritas.
Veritas, and you guys.
Then they were, well, no, Alliance bought here, the LDAR division, and then we were with the EMSI before that, and after they bought Bureau Veritas, they actually purchased EMSI.
Yeah.
It kind of marked in the two programs merged together.
Yeah. So
Okay.
we're with Louis, Legacy Summit, so.
Okay, it's great to hear. I know I've talked to Louis, and he said, you know, he's spoken really highly of the people that he has on site doing all this stuff out there. So it's definitely great to hear information. We're going to you'll see one thing a little bit later in the presentation. It's kind of what I was talking about, how we correct stuff and things like that, and, or identify these. It's called a headed metric. It's actually Andrew's brainchild of how he put everything together. Amazing what he did with the predictive analytics to identify this. So we'll probably institute that out there.
No, that'll be
And,
great.
my goal is to have it every month by the end of next quarter. It's a lot of data to collect and compile and do things like that, just because the implementation is easy, but when you don't want to roll it out too fast, because then you don't have it zero and messing something up. But so y'all should be seeing it by the end of next quarter. So.
I know Lewis had showed me some tools, but I couldn't remember if they're Alliance tools or if they're ED tools.
Well,
So.
yeah, Alliance, we've actually, me, Andrew, and the compliance group working with Lewis and the other area managers, we've actually just implemented a lot of stuff. It's kind of a combined thing of what Summit and DB did and what EMSI was doing. So we're kind of taking the best of both worlds and making it into Alliance, because when they purchased us and I looked at everything they were doing, obviously there was some stuff we were doing that we wanted to add on there, but there was stuff that they were doing. And I hadn't even thought about that yet. So kind of got one of those best of both worlds situations.
That's always a good thing. There's that's best.
Oh, yeah. Yeah. So, yeah, you'll probably be seeing, you'll hear the term VHS inside metric and CARD program, which you already heard the CARD program, because that was a whole BP one.
It's possible that I thought but not knew that there's an acronym along with
Oh,
it.
yeah. Yeah, all those, we've officially found a way to make them all together. So now we're just putting it out in the, where we don't overwhelm the guy that's out there actually running the program and checking them to get somebody 900 new to implement one day. Or
Yeah,
it's not feasible. I mean, there's been normal to us. They're improvements, not a work. Right. So it's like one of those. Don't rock the boat. It's going great. Just add a little horsepower here and there. So that's
that makes sense. So, thank you.
fine. All right. I might not be back right when we first start this.
Or
I'll go in.
okay.
So technically.
And next,
She's moving. Oh, wait, you walk, right?
okay. Yeah.
Get going on this first part of this. Atmosphere.
Yeah. Well, the predictive analytics is usually pretty good. I'm probably gonna cruise through this section pretty fast and then get into predictive analytics.
Yeah, predicted that. Sure. You actually get a break.
You wanna make sure that. So did everybody get one of these? looks like I'm getting closer to my comfort zone. So this is pretty typical of my speeches. Anyway, but all right, let's get going again. So this is everything we just talked about. Method 21 is a skill. I always like to talk about that because, you know, I like to be able to recognize, you know, the really good technicians, and then hopefully you can, you know, convince the powers that be that, hey, these guys are standout technicians. Perhaps they need to make a little bit more money than some of the other technicians because they're very good at what they do. It's a skill. And the other thing I like to mention is, you know, you can kind of take this knowledge and think about when it is you go get your hair cut. So I've kind of gotten to where I don't like to get haircuts like on, say, you know, well, Tuesday is usually the Monday for people who cut hair. So, you know, if you want the best quality, you might want to go to like Wednesday or Thursday. But anyway, I digress. So, you know, the ways of, you know, reducing costs, everybody's always, you know, wanting to talk about how can I, you know, under the same budget, you know, we have to start talking about, you know, what are the newer technologies out there. Method 21, it's been out there for, you know, over 20 years, and it's not, a lot of people don't consider it as being state of the art. You know, perhaps some of the ways that you look at the data might be state of the art, but the actual method itself is not so much. So we're going to look at, you know, some of the things that are out there now, the fence line monitoring, the mobile ambient air monitoring system. You know, of course, the FLIR camera is kind of starting to get old now, but I mean, it's kind of the newer point source. And then the predictive leak management system, we'll get into that a little bit. And of course, predictive analytics. Since we're going to be talking a lot about predictive analytics in one of the other modules, I'm going to kind of go through this part pretty quick. So the fence line monitoring studies, you know, a lot of places are being required to do this now. I know you know, we picked up a few, you know, contracts. There was like a 114 request from the EPA for a lot of the chemical plants and stuff to go out there, and you know, they weren't required to do fence line before, but they want to do like a 6-week study, or I guess it's more like a month and a half, but they want 3 rounds of this. So we have to actually do it just like the refineries do at these chemical plants, and place these sorbent tubes at every 30 degrees, or yeah, I think it's, yeah, every 30 degrees for the most part for most places, and do this for, you know, 3 months. So that, yes, yeah, it's mostly all benzene. It's benzene, and then what was the other one? Yeah, there was benzene, and there was there was another stream. I can't exactly remember what it was. Yeah, this is all brand new, and this is stuff that it's like they're having to figure out right now how much benzene is out there. So yeah, it might be 1,3-butadiene. I think it's the 1,3-butadiene is what it was. Do they? Yeah, reportable quantity. Yeah, I can talk. Well, I'm going to save that discussion towards the end when we start talking about why they're implementing some of the upstream stuff. You know, I've had the chance to, you know, do some work on the upstream. You know, looking at some of the wellheads, and did a study at the Alabama Coshada Indian Reservation, which was very interesting. But I was just looking at benzene, but we'll talk about a little bit more about that later. So the fence line monitoring, it's great because it's out there 24/7. You know, it's really good for saying, hey, we have these emissions that are planned. It's not so great about saying, hey, where are these emissions coming from? You can look at predominant winds And a lot of times in Texas, you do have a predominant wind, so you can kind of tell that, hey, these emissions are coming from this tank farm over here next to this fence. You know, the clients are always interested in, hey, can you prove that this didn't come from, that this came from us and not our next door neighbor? Because we think it's our next door neighbor who's emitting these. So they're always wanting to know, figure out how this is, you know, where is it coming from? A few different kinds of different, you know, this is an open path optical. It's also, it gives you more of a, you know, hey, we're getting a hit right now. So we can kind of go out there and we can get a better pinpoint as to where that's coming from. The bad thing is they're expensive to operate, expensive to maintain. But it's real time data, so that's a big positive. Here's a good picture of the van I had built. You know, it was from a grant from the EPA, but did a study for around wellheads. This was us parked next to you know, pretty typical tank battery at a wellhead. You can kind of see the mast that I had that could extend up to about the same level as the tops of these tanks. And again, this works in real time. It was a great study. You know, this is starting to get more and more popular right now. I know they have some stuff that's even better than what I had. You know, my stuff could monitor, you know, it would take samples every, you know, 6 minutes per machine. So we had them staggered, and I was seeing, you know, stuff coming in every 3 minutes. You know, also had, you know, built-in meteorological stations, so I could tell exactly where the wind was coming from and all that. All this data that we collected, it all went back to the EPA, and it went into some of the new rules. Another cool thing about that van, y'all remember the ITC fire? All during that fire, I was, you know, at least for the first 2 weeks of that fire, I was driving around 24/7. You know, they didn't necessarily want me to, well, they did want me to be in the plume. They wanted me to like stay outside of the plume, but they wanted me to kind of canvass, you know, a lot of the residential areas to make sure that they weren't being exposed to benzene, and there was quite a bit of benzene coming out of those fires. The bad thing about this is calibration's kind of difficult. I'm not. You almost have to be an instrumentation tech to keep these vans running. It was a lot. So another piece of technology is the FLIR camera. Everybody's pretty familiar with these. The main things, the limitations of the FLIR camera, contrary to what people would like you to believe, they don't find the leaks as low. You know, a lot of them say, yeah, they can find stuff down to like 500 ppm. That's not the case in our experience, and I'm going to let Aaron speak to that a little bit. You know, normally, you know, when people come to your facility and they do a FLIR camera study, all the leaks are usually around 10,000, 15, 20,000 ppm, wherever you go back and recheck them. They're almost the type of leaks that almost blow your TVA out when you go back and double check. Every now and then you'll see an 8,000 ppm leak they come back with, but you don't see a whole lot between 500 and 10,000. The primary benefit to the FLIR camera is the frequency of monitoring can be increased to the point that if any big leak does develop, you can capture it quicker. That's the biggest pro for that.
And before we move on, I'm sure everybody here at your facility somewhere, if you haven't already used the FLIR, probably have planned on using the camera there, because they are a very, very good tool, especially if you get, say, hey, there is an odor in the area, or you're getting a very bad day where you're saying you don't know what things are leaking. It'll let you see it where it's coming. But if you're doing like unit surveys and things like that on a routine basis, have it scheduled and not like, because one of the things that, it's highly recommended and it's required in AWP practice plan is doing a gas check with, just like method 21, even with a clear camera, wind changes. So you need to do what a gas check is with the camera. It's not natural calibration, but you get a methane bottle. You have a regulator where you flow, the actual flow out of there of something like pure methane. And then you actually use the camera to see how far away from it you actually see. Depending on the weather, it changes, which days, obviously no wind is flare camera that there's a sweet spot around, 3 to 7 miles an hour where you actually get a speed. Once it gets up to 10 to 15 miles an hour, distance at which you can see that leak drastically, right? So doing that gas check in the morning actually detect anything, lets you know what range you are. As sometimes you can see 5,000 to 6,000 people. Sometimes it needs to be 2,000 people fired in actual environmental conditions at the time. It'll never detect as low as the actual heat. I know I've sat through a lot of clear trainings here where they say they can cut as low as 10 ppm. Anybody that's ever saw a 10 ppm reading or even a 100 ppm reading outside of a vacuum, a vacuum area where everything in a lab condition, please tell me, because since they came out, I have not. Typically, your readings are in the vacuum, in the vacuum. Right. But it does allow you to find those big leaks. You all know, if you've done an emissions inventory, 1% of your leaks, about 60% of your people.
Yeah, as you mentioned, the 10 to 15 mile an hour leaks, remember that curve that goes throughout the day. So chances are, if you're doing a fluid study, you'll find more leaks in the morning when the wind is calm versus in the afternoon when the sun, the sun plays a big factor. If it's a cloudy day, you're probably gonna be able, have a better chance. But with the sun and the shadows and then also the wind kicking up, it becomes very difficult to find those leaks later in the afternoon with the FLIR camera. So, here's a few positives. I mean, new startups, really great use for the FLIR camera. I'm not saying that nothing else is, but I've seen these startups of some of these newer NGL plants. I walked around some of them, and you don't even need a camera. You can smell it. You'll get a headache. Sometimes you can see it with the naked eye. You can see the little, looks like the gas coming out of your when you fill up your car. I mean, I'm sure not. Some places are better than the one I'm thinking of right now. I mean, you could, I remember monitoring around a compressor, a huge compressor, and then some of the bolts, where this compressor bolts up to these, 16-inch flanges, or it might have been 20-inch, but they're like just hand loose. I mean, they're like rattling inside the flange.
Yeah, and if you're at a facility and post startup, when you first start up your process units, or after, maybe you didn't go all the way down, but you had a major process unit upset where you had a drastic pressure change. It is highly recommended that you have something in there where you do just a flare camera survey, something that, method 21 might take you days or even weeks, depending on how big a unit is, to go check everything. But if you do that flare camera survey right away, you can identify those issues, where something wasn't torqued properly, or a bolt was cross-threaded, or just during the general pressure change of startups, there's a reason why people aren't allowed in the unit outside of, operations personnel when they're starting up and shutting down. You have a lot of pressure changes. That's when something's more likely to happen.
Now, is this something you guys have for your fleet, or is this something you're
We actually, we have, about 10 or 8 flare cameras that we use, that go different places at different times for different jobs. We have several facilities that have one that they, they've requested to keep on site full time just for troubleshooting. A lot of facilities that we use, they don't necessarily have our flare camera out there. They've actually purchased their own and operated with them. But it is something that's definitely readily available anytime somebody needs to test it. If it's a startup or something shut down, I always typically recommend they are in high demand with a lot of the new that are coming out. So the more notice, the easier it is to make sure one's on site. But typically there's usually one in any company, and especially with us, sitting on a shelf just ready to go because they're needed for quite a few things and can identify and be a huge benefit for us.
Yeah. Yeah, the need for them is definitely ramping up, and we'll get into a little bit more. One of the good uses for our flare camera, and we talked about, the fence line monitoring. If you do get these hits, the flare cameras are really good at, going in there and saying, okay, is it this tank or is it, because you can really look at bigger emissions, and it's the bigger emissions that usually lead to these fence line hits, not necessarily the smaller.
Yeah, so they do detect propane very well. So what I've seen is, like, for instance, if you're doing method 21 in an area, you got a high background. You're getting a background in the area. The flare camera is great at narrowing down exactly where that is. That way you can get that leak, because there will be times where you have a propane leak, whether it's a loose piece of tubing or maybe a hose, a type of equipment where it's leaking from. It could cause you to say something is leaking that's not really right. I'm sure if everybody in here in environmental's probably had a maintenance person upset at some point because they hit something next to it that wasn't actually right. That flare camera can tell you this is leaking, and you can avoid checking the rest of it until you fix that big leak to be able to know for a fact everything else you're not picking up background from that. Same thing goes with, plugs, tubing. You see it a lot of times on there. On the bottom of heaters, if anybody has a heater with a lot of fuel gas or what's called natural gas injection, on the bottom of it that you're looking for, a lot of times you're getting background off of either a burner that's, not sucking all the natural gas in like it's supposed to, or, you just have one connection that's leaking that's causing like 20 around it to say it doesn't. Hopefully that answers the question. Yes. Yeah, they are great for finding that leak that's not able to be found. And just a real world example that I've actually, it happened for the second time finally, a couple months ago. I had a facility that had they had an odor complaint, right? And then they also had some of their area alarms would occasionally pick up LDLs or something in the area. Nobody could find where it was coming. Sent people out there with TVAs, tried to track it down, couldn't find it. I went out there with the flare camera, saw a small plume, and come to find out, right, something that's not even in DOC 30. But 150 yards down that conduit, it was connected inside of an or inside a box on the side of a compressor. There was a small leak inside that box on the compressor, and that box was airtight. The conduit was airtight, and that was its only path out. So it traveled down that inside of the conduit about 100 yards till there was like just part of the gasket on the plate, elbows on the conduit, and it was coming out there. And nobody was actually, who looked for a leak on a piece of electrical conduit, right? But the camera was able to see it, see the plume, trace it back to that exact point. And when I told everybody it's coming from the conduit, the first thing that their first response was, "You're crazy, that's electrical. You can't have a leak from there." And then I show them a video And instantly everybody's like, oh, and start backtracking it, find exactly where it's coming from, and we're able to actually correct the issue. And it was something that had been going on for a few weeks that nobody could figure out, but in a 1 hour flare camera survey, we were able to find it. And it happened, you know, just exactly like you're saying, you got a leak somewhere, but nobody can find it. The key is don't just look at the normal stuff. You have a camera and you can scan everything in the area. And once you see a little bit of a plume, you can back trace it to see where it's coming from. And usually those things that nobody can find where they're coming from are coming from something that they shouldn't be coming from, or it's not supposed to be possible that it comes.
Yeah, so well, one of the ways you can really reduce costs with the FLIR camera is looking at your DTM components. You can cover a lot more DTM components with the FLIR camera than you can with the regular Meta 21. Meta 21, you might be able to get 50 to 100 a day. You know, FLIR, you can probably look at 1,000.
So you would do a gas check, right? So there's technically a calibration for the FLIR camera. That's something that the actual manufacturer does. There's no routine like daily or weekly calibration. It's called a gas check. And that's where you would actually do what we were talking about earlier. In the morning, you set up that bottle, you set up the known flow rate of methane going out and see what distance you can see it at, right? So if that distance is only about 6 feet in the morning, it would not be a day that you could do a DTM, right? But sometimes that distance is 50 or 60 feet where you can clearly see those leaks. And, you know, when you have a distance, as long as you're within whatever distance you can see that, see it at in your gas check, then you can be sure that you're getting an accurate reading, right? That's why the AWP, or alternative work practice plan, that allows you to do FLIR camera monitoring in place of Method 21 actually requires that gas check. But general, you know, hey, I'm just doing a survey of my facility, or there are some consent decrees out there right now. I know of a few facilities we do work with that just requires you to just do a general FLIR camera survey, you know, once per month for, you know, an individual unit. And in those, they don't have that requirement, but even if you don't have that requirement, the only way to know that you're truly being able to see stuff and what distance you can see something at is that morning gas check.
Yeah, so when we built this particular module, we were trying to figure out, well, where can FLIR camera really save you money? And when we're talking about, you know, doing DTMs, yeah, I mean, when you monitor Meta 21, you're monitoring, say, once per year, typically for a DTM. As we talked about earlier, there is a variable amount of quality on that, every one of those DTM checks. So maybe they find the leak, maybe they don't. Hopefully they do. But you know, to us, it's probably a more thorough check than with the FLIR camera, because you typically find out a much lower ppm. But the thing with the FLIR camera, you can do it more often, you know, because you're not, you know, with the FLIR camera, it's not really even difficult to monitor. It's, you know, it can become just you can do it every 2 months with the FLIR camera. If anything starts leaking at a high enough rate, you can be on it and get it fixed right then. So at that point, you're actually reducing emissions, because these, you know, leaks aren't persisting throughout an entire year or more before you're actually getting to them and getting them repaired. And as you mentioned, the really big leaks are the ones that, you know, cost you more, like 60% of your emissions from monitored components. So, yeah, I'm not going to kind of go through all the numbers for those, but they're all going to be on the slides if y'all want to look at them a little bit more closely. Meta 21 plus predictive analytics. We threw predictive analytics in here because, you know, it's what we love to talk about. Plus, you know, predictive analytics, you know, something we can do now that we just weren't able to do, you know, 10 years ago. The way we can crunch through the numbers, you know, look at the data. That data, I remember 20 years ago, we were using floppy drives, 15 years ago, maybe we started seeing, high-speed internet or in some places. But yeah, not until the last 5 or 10 years were we actually able to crunch numbers to the extent that where you could pull in a large size amount of data on a good laptop and actually, run these things. The way this can actually save money is that if you're using something like predictive analytics, you don't have to have as much supervision on your employees. You can kind of go directly to the problem areas. Now, remember we talked about the supervision thing. Remember on Friday, monitoring quality, at least at this one site, because there wasn't any supervision, it just went to hell. I mean, there wasn't anybody finding any leaks on Friday until, we went and looked at the data and realized that the leak rates weren't there on Friday. That's when we figured it out. Predictive analytics is a little bit more pinpoint than that. I mean, you can tell if anybody was messing up on any particular day, and then you can kind of go directly to that area where they might have been messing up, and you can have your supervision go out to that particular area and monitor behind them and find out what the deal was, So it saves time in that instance because perhaps you don't have to have, back in the day, you knew who your good guys and your bad guys were, but you couldn't always necessarily pinpoint your bad guys because they would say that you were picking on them. You couldn't do that. So you'd have to check behind, 20 people in order to get to that one person who you're really, wanting to get to. And then you may or may not find something. So sometimes these bad actors will persist for months before you had enough stuff on them before you could actually do something. So anyway, that's the Method 21 plus predictive analytics. It does save some time, better than just the Method 21 by itself. And again, talking about today's personal computers. The predictive analytics are pretty much accessible by everybody. Everybody can do big data now. That used to not be the case, but everybody can do big data. So, let's see. Getting directly into the predictive analytics.
Yeah, there's a lot of slides in here that actually tell you about just kind of how they build the analytics. To the tech metrics section, we can kind of explain it while we're going through those, and y'all can kind of see.
Yeah, Aaron wants to get to his section. He's like trying to hurry me along. He has a lot to say, apparently. So, so predictive analytics. So what we're doing here is we're extracting data from existing data sets to try to predict the future outcomes. LDAR data is perfect for that because you have a trove of data that you can look at. The data from Method 21, it should kind of give you a good idea of what the current monitoring should look like. There's a certain amount of reliability. It's not 100% accurate, but it's always, math is always 100% accurate. There's always a reason why it may be off. It could be, a number of reasons why the monitoring isn't looking like it should be. Sometimes, we find that they're monitoring components that are out of service. That could be the case, or perhaps they're monitoring in high wind situations or some kind of a deal. But that's what we kind of look at. The predictive analytics as a whole, I mean, it can be used in a number of different things. It can predict equipment failures. We've tried to get our hands on all kinds of data, and we did do some studies, to predict a certain amount of, or when certain components should start leaking based on the vibration and temperature and stuff like that. It is perfectly unbiased. So I always like to kind of talk a little bit about the NFL passer rating. I know it was probably during the football season. It was whenever I initially put this stuff together. So it was relevant then. But the NFL pass rating is a really good example. It kind of, they try to say, well, this guy, he over the last 5 games, his quarterback rating was like a 67 or something. So, we don't predict that he's going to do that well in the next game. So maybe you ought to choose another quarterback for your, what you call it, your fantasy football team, I guess. So the average on that was about an 88.6. Here, if anybody's wants to know exactly what goes into it, this is the computation for the NFL passer ratings. So in leak detection, a lot of people in the past, they always looked at the minimum inspection times, the time between monitoring events. We started doing that about 20 years ago. We found that over the years that's become a less reliable way of predicting quality and monitoring. And it's mainly because as time went on, LDAR companies got smart, and we eventually started programming them the amount of time that you can spend on a certain size component based on, so say a 4-inch valve requires you to stay there for, say 20 seconds versus a 2-inch valve, which may be required you to stay there for like 16 seconds. So as technicians started using this, looking at the timestamps became less and less reliable for doing quality because, quite frankly, the handheld became the best tool that a technician could have for falsifying data because it made all the data look good. So you couldn't really rely on that anymore. And some people still do that. I mean, you'll get, I won't name any names, although I really want to, but they put a lot of thought or a lot of effort into these timestamp evaluations. And I mean, I've looked at them, I've compared them to the people that I've done other studies on, and there really isn't a whole lot of correlation between how well a technician does and how well their timestamps look. Did you have a question back there? Okay, I thought. GPS coordinates are great. I love them. The only problem with those is, most of the companies that utilize those, they don't start looking at the GPS coordinates until they have a suspicion that somebody isn't performing well. And yeah, you do get the occasional technician that maybe, maybe they get the idea that nobody's looking at these, so you do get the occasional, hey, I got GPS coordinates outside of the plant on these monitored components. But it's not a really good, thing for, finding quality all the time. So,
and just where he was talking about the LDAR database, right? So there's several LDAR databases. The main ones typically right? And those databases now, based off of the size component, actually allow you to program in minimum. How less than 50 seconds, you program that in. Makes it impossible. Now, the reason why in the past the content set had a lot more in depth on how monitoring it, that wasn't pre-in for makes it by size people. Now that that's pre-programmed in, which you do want it programmed in because that ensures that having those not having to lag or anything like that, right? But all because the handheld says 5 seconds, not mean the program early, they might take their probe off. That it will still show them monitor. So it's just became a little, still, it's a valuable tool that has audit readiness, but kind of hinders you as far as what quality, what make it full findings in an audit, but it kind of takes it away from the supervisor being able to look at that part of the data. Truly, the only time that anything ever flags on those is affected, added, and monitored. It's set, it's still a valuable tool. But after you've set that number, really you've made the database. You'll see it extremely long time. That could be a flag, but Andrew not going to. There are reports that you run in every, if you do see stuff flagged, sign that your database is. And follow up. That's more of a database. That's probably mine.
So in LDAR, I mean, the question is, what is good for a metric? Well, the readings are good for metrics. The reason that readings are good for metrics is because all those readings below 500 or maybe 100 or 200, if you have a consent decree leak, all those lower level leaks, they always persist. So a 50 ppm leak, if it was there 1 month, or 1 quarter, it should be there the next quarter and the next quarter. As long as it doesn't get fixed, those lower leaks, the 10, 20 ppm leaks, they should always be there. So all those leaks that don't get repaired, they become like a fingerprint for any given group of components. And so that's the idea of the predictive analytics that we use. It's all based on that theory that all those low level leaks, they always persist. So we look at, and normally 2.5 years worth of data. More recently, it's been 2 years because we kind of feel like you want to compare the same number of seasons against the same number of seasons. So you don't want to compare the current monitoring to 3 winters or 3 summers, So all the data, we found that 2 years is probably a little bit better, but doesn't make a huge difference. The key is, you have like 8 or 10 monitoring events. You average them all together. You know where all your elevated readings are. You can compare your current readings to all these older elevated readings, and then you can put together a rating based on a composite score, various metrics within the same data.
And one thing to add on, why we settled on a 2-year standpoint. We work between 2 and 2.5 years. The reason why we don't just look at everything forever, right? Just back to the beginning of the plant is LDAR is a 2-phase program, right? There's the leak detection and then the repair side, right? So if you look at everything forever, you kind of take out the effectiveness of, hey, our repair program is getting better along with the detection standpoint. So that 2-year standpoint is where we found that kind of sweet spot when Andrew was crunching all these numbers, where you can see the true a trend on the detection standpoint and how accurate it was, without not being able to factor in how well those long-term repairs are, especially with a lot of the consent decrees out there that require low leak technology upgrades or preventative maintenance at 100 ppm or 200 ppm, whatever it may be. That 2-year window seems to be the sweet spot. If you go further than that, you start seeing your scores a little bit lower than, they're not, they show a little bit lower than what they are when Andrew gets to kind of what he does with all this data. And if you go shorter than that, you just don't have enough data to get an accurate than that. So that's kind of why he fell on 2 years instead of 10 years or 15 years if the plant, if those units have been there a long time, because not only is the detection side getting better throughout, from year to year, and technology improving and people getting better at their jobs, the repair side's getting better to minimize stuff as well. Kind of factors in both sides.
Yeah, as time goes by, there's a couple of things I want to mention. As time goes by, as you said, you get more of the stuff repaired because your monitoring is more accurate, but then that becomes the data that you're comparing to. So the data becomes better. So, and as we lop off the old data, then all of a sudden all you're comparing to is good data. So sometimes your scores start to drop a little bit but we know all this and we expect that, from a good program. The other thing is, we typically, if we know the install dates on components, we don't include them in the study until they've been in the LDAR program for about 90 days. That gives them a chance to get repaired. So we don't necessarily. No, so 400 data points. So when a technician goes out there and monitors, they monitor 400 components. Each one of those components has, say 10 previous monitoring events that we can compare it to. So that when I'm talking about the 400 components, it's always going to be the 400 components that they're actually monitoring.
Yeah.
So they will always have their own data that we're using to determine how good that current monitoring data is.
Yeah, and here in a second, we'll have a couple slides of what it does with all the data, but it's really just the point of that is in most third-party audits, they're looking at leak rates for units. By using the analytics that he's talking about, instead of just looking at it for like a whole unit and comparing it to what that unit's history are, you're comparing it, whatever components they monitored that day, whether it's 400, 250, 550, you're comparing it to those exact same components every time instead of a back.
And since we've been doing it, and we'll get into this a little bit more maybe, I'd like to say, kudos to all the women. Women make very good monitoring technicians. They typically, for whatever reason, I don't know why, but they're usually, once we're able to start looking at the quality of the data, women, the guys need to step it up, is all I'm saying. Making us look bad. But this is typically kind of what it looks like. You got usually about a third in the green. The yellow is not too bad. I try to make it to where the scores that I have there in bold, or I don't know if y'all can even read those, but kind of similar to what you're used to seeing with the quarterback rating. Normally you're only going to have scores in the higher triple digits if you have people scoring in the negative. A lot of times when you may see a group of people that everybody's kind of a lot more closely grouped. But yeah, the only reason why these guys are doing so well is because there's other people that are not doing as well for finding leaks. So they're able to go in there and monitor behind other people and find all this stuff and hey, I'm doing great.
And this is what we were talking about earlier when I think the question was asked, what can you do to confirm, the accuracy drop that you see on Friday, not picking up everything that you do, like on a windy day. What we've developed is, this is actually what we call the tech metric. It's actually 100% built by Andrew here. We put all of this stuff together. We refined it over the years by basically truth testing everything that we found in the field. So what it does is it compares everything that the technician did out there between, not just leaks, it factors in, leaks compared to what we found before, reading compared to what it found before, and agreement, leaks, elevated readings that we find elevated readings. Identified a few things in there and built them into the system that allows us to identify, is somebody trying to beat the system? Because there's always somebody trying to beat the system, whether it's, when you're driving, you're trying to go 5 miles an hour over the speed limit, saying it's only 5 miles an hour, I can't get a ticket, right? Somebody doing that with, monitoring, oh, I'm just going a little bit quicker, I won't miss it. or somebody that's just outright just doesn't have, the high integrity that you need to record all this data, right? So he's identified all these factors and built them into, it's a pretty complex equation that he has them built into that actually is able to give us an analytical score on how well that person did that thing, right? So he has them broken up into red, yellow, and green. With the scoring ratio and how he does it is pretty much anything where they get a tech rating score of above a 50. We have, we can say with high confidence what that person did that they could withstand any audit that was thrown at, right? No matter what audit, who goes out and audits their stuff, they're not going to find anything that doesn't look like. Yellow, we have, a general certainty, most stuff should be good. We don't have any real concern. And when we flag them in the red, that is, hey, something doesn't look right in this data. We need to go out there and audit it. Does it mean something is wrong? Like instantly, hey, they're in the red. They didn't do their job, right? No, it doesn't mean that, but it means that's the highest level of where you'll find something, right? That's where you'll find, hey, somebody, if they were end of the day Friday, they got 300 on this component instead of sitting on it a couple extra seconds or maintaining that proper probe angle until they got over a 500. Actually identified it. It's something as simple as it's not leaking, but they didn't get the elevated reading that should be expected. So we find that sometimes we find everything was 100% right? And, basically the components that we expected to see higher readings, when we look back on those components, they had very good maintenance, right? And that's where, it's something that it really directs exactly where we're going, right? So where in the past you've got a unit, right, and you're trying to confirm the accuracy of your monitoring, if that unit has 10,000 components, you're checking, a few thousand of them to say, hey, we didn't miss anything in here. That's what all third-party audits are. If they come out there and they check 10 to 15% of an entire unit and then just compare the leak rate. By using the predictive analytics and all the scores that Andrew's put together, we're able to actually go out there and say, hey, everything is where we expect it to be, except for these 25 components. And we're able to go out there and check just those 25 components. And we're able to find what was missed in those components, right? If anything was missed, we might find 5 or 6 leaks in there where we can figure out what the root cause of that was. Was it an improper technique or was it somebody just not doing their job at all? But it allows you to do something where in a big facility or even in a small facility, when you have 900 things that you're trying to do all at the same time to confirm your accuracy, it shortens the time frame on like supervision and QA/QC people, or we can go to the exact problem areas and not have to, just hope we fall across the problem areas while we're checking an entire unit. We can go to these exact components, and check those and, either find the leaks to get an accurate leak rate for the unit, increase that to make sure that we're ready for all the audit, or B, confirm that, hey, maintenance has got better in this unit, or, whatever process changes have been made, whether, hey, they used to run it, at X pressure and they back down because they just don't know. They're not, there's not a high demand to be running at such high pressure or something. And you've just had pressure changes that have affected your leak rate. But what we're finding is accurate. Hey, we got lower leak rates this time through. We confirmed it, and we also found the cause of, hey, they were running at 50 less pounds pressure than normal during this monitoring period. So if 2 years from now, that 1 quarter is flagged because your leak rate did not match what an auditor found or an agency person found, and they say that, you're able to confirm that the monitoring is accurate and what the cause was and why you have a lower leak rate during that time frame. So you already have the verification, right? So it just allows you to have that high confidence and high certainty of, the data that you're submitting to agencies, that you're using for every one of your reports is true, accurate data, and you're reporting accurate as possible data, and all that you're minimizing the human errors that come with the nature of humans going out there and collecting data at hundreds of points per day, right?
Now, so and this is a good example. This is the same facility, this one in the next slide. It allows us to, kind of look at the guy in the red, or it might have been girl, I don't know. But anyway, it allowed us to kind of focus in on those problem areas without having to look at everybody. And then as the technicians know that you're doing this, the monitoring improves. Yeah, the technicians do know we're doing this.
So it depends on what they're doing, right? There is no true max, hey, you can't do more than the number that we continuously set. We do have some site specific, but we don't have a company-wide max number. Because we do have, like, for instance, we have some facilities where we check all the pin fan, right? I can tell you just from experience, I can monitor a fin fan plug with accuracy and find the leak on it in like 10 seconds. Right? And if you have, a row of fin fans and you have, there can be 30,000 plugs on that. You're not going to check all those in a day, but you can definitely check over 1,000 of those in one day. Now, if somebody goes and does a normal route and they check 1,000 valves in a day, there's going to be like red flags flying everywhere. So it's not a set number. There are general guidelines that, we kind of identify by situations, right? Are they monitoring just valves, or are they monitoring the valves and the connectors? If they're monitoring valves and connectors, are they on an analyzer house, or are they on like a pump station? So there is a set number, but it's a variable set number based off of the situation.
Yeah, and
Yeah, there are reports in most of them that you can just run. And what we typically do in our QAQC tools, and what we do is, for instance, in leak dogs, we just run the monitor and productivity by inspector each day. We verify the numbers, and we know, the supervisor who's looking at those numbers knows where everybody's working at that day, right? So he has that general guidelines of, this person's doing fin fan plug. I'm not going to freak out if they did 850. This guy's in the tank farm just doing valves. I even see 550 on him. I know that's a big issue, right? Because you can't do it. So you can run those, it's a monitoring productivity by inspector and leak dogs. And then in Guideware, there's just a general report where you can actually see anything above a certain number, and you can set what that is, see anybody that monitored above that number. But it always does fall back to reviewing exactly what they were monitoring. Right? If somebody in a tank farm checked all the, 1,000 components, that's just not possible. But a fin fan, analyzer house it is.
yeah, yeah. Yeah, my thing on that is you can get, that 750, 800 number, as long as you have a method, such as this, and I know a lot of other LDAR companies have similar stuff, at least internally they do, but as long as you have a way to check for the quality, and I mean, on everything really, but if you check for the quality across the board, then you should allow your technicians, especially your more skilled technicians, to get more components. So I don't necessarily freak out at the higher numbers, as long as I can go back and look at their quality for that particular day, and I can say, well, they hit all their marks, all that stuff looked good.
The key about the number of the day, which to go piggyback off the point talking about where you document that, why they were able to do it in that system. That's something that you should definitely do, because I'll tell you this, any third-party audit, any agency audit, they're going to give you a list of everybody that monitored more than 600 components in it. They're just going to say, hey, this looks fishy to me. They're not going to look any more into it than that. Typically what you do is you notate, then plug, analyze, go through that. Something that you prepare on your daily QAQC is good, but regardless of how many components that somebody does monitor in a day, that is, that's an indicator to look for, but typically you're not going to see somebody in a tank farm, come in and say they did 700, 800, right? You're only going to see that in areas where they can actually get that many. So, I mean, key focus is I think that is what Andrew's saying is, having a tool that looks at the accuracy of each individual one is really that's going to be your key indicator. Because it doesn't matter whether somebody monitored 100 who was really slow, that could be a very bad 100 components compared to somebody who monitored 500 in that same area, but his accuracy level was higher. So the number of components, you always need to have that data for audit, because whether it's a key sign of the accuracy or not, the agency's going to ask that question. Every third-party audit that I've ever had conducted on me asked that question. I ask that question when I do third-party audits too, so it's something that everybody does ask the question to see, could you monitor or why this was? But that's really just asking for a justification and really making sure that whoever is looking at the data is looking at it to see, hey, can this really be right? But the accuracy and having something built in where you actually are looking at that accuracy, and then not just looking at it, but in the field doing some sort of a comparative monitoring, that is the key to make sure that you're prepared for an audit. Because out of everything, most people, your databases, we run enough databases checked, and most companies, there's enough checks where you make sure that you're checking what you need to check. The two big findings and two things, which we have a section coming up where I'm going to talk about auditing and audits that are issues that raise the biggest red flags everywhere is your leak rate is way lower than whatever an auditor, right? Agency, that's going to set off bells, and they're going to hammer that to the end of time, right? And then undocumented. It's those field issues that you have to see in the field, or you have to confirm in the field. And plants are just there's so many things in a plant, no matter whether it's a big plant or a smaller plant, there are still thousands and thousands of plants. And you can't really look at every single one of them in your QAQC unless your QAQC takes longer than actually doing work, right? So there needs to be a way where you drill down and see exactly where the problem areas are. That way, when you're performing that QAQC, it's an effective QAQC, because you could go out and do any comparative monitoring audit, right? But if you happen to go do a comparative monitoring audit in a unit that never leaks, or an area that just never leaks, you're not going to find anything, even if they weren't right? So you want to try to direct your stuff to the areas where, hey, will find stuff, because those are that's the key that'll give you the best accuracy of all, make you that's prepared for audit. I mean, end of the day, our goal, well, the primary goal is no harm to the environment, right? We all want to protect the air we breathe, land we're on, and water we drink. But the secondary goal, we all want to be prepared for these audits and have good audits. I mean, that really is, at the end of the day, that's the report card of what everybody in here does. How well you perform in audits, how, the decrease, low number of deviation that we guys, right? So that's something you always want to make sure you're prepared for that. It'll show the strength of your program.
Yeah, so
Having those direct.
this is real data. And apparently this is, well, not apparently, I know this is like 2018, 2019, because some of these techs I know are not with us anymore. Joe Flacco no longer is with us. Neither is Drew Brees is no longer with us. So, I mean, some of these guys have kind of fallen by the wayside, but this is some real world data that we had to, do a couple of interventions on. And the idea here is that, yeah, we had, some guys that scored in the negative in March and April. Baker Mayfield did. And then we did a intervention on Baker Mayfield. All of a sudden the next month he did better. So instead of, these guys, perpetually doing poor, we can sit with them, do the interventions. We don't necessarily want to, get rid of anybody. We want them to get better. And then they, we do the intervention and all of a sudden they get better. On this month of, let's see, what was it? August, we had to do an intervention with Dak Prescott. And then he did turn it around the following month. So then Brock Osweiler, we're still working with him. But that's kind of how it looks in the real world. But what we can do is, we can assign scores to all of our different sites based on how many people are in the green, how many are in the yellow, and how many are in the red. Then we can look at all of our sites, and the more people who are in the red, those are the sites that need all of our compliance attention. So we can focus more resources on the ones who are on the sites who are doing poorly. Every LDAR company, they all have these certain sites that it just seems like you have too many rotten apples or something. I don't know what the deal is, but they're just hard to manage. And we know what sites those are now, and then we can just kind of jump in there and look at them. Somebody also was asking about some of the softwares. Guideware was nice enough to work with us. This is in every Guideware now. You're allowed to put in a modifier for the amount of time that they can spend on their components. So a 1 modifier, you can spend the same, the shortest amount of time. Or a 1.5 modifier, they can spend like time and a half on those components. So the idea here is that if the guys that are doing well, you should be able to allow them to go a little bit faster with their monitoring. The guys who are either new or performing poorly, you put them at a 2 modifier, you're requiring them to spend twice as long at each component. So that, as long as and it's almost a reward to the technicians to be able to go a little bit quicker. It gets them a little bit more involved in the monitoring. It keeps them, keeps their head in it.
You guys have a contract. Something you guys monitor part.
Yeah, it's something that we typically will update, and now we do it site by site basis because certain facilities, they want you to stick within this because they have it posted in their LDAR plan, right? So if something's written in your LDAR plan, I mean, you need to follow exactly what that is to stay within, compliance of that. But yeah, we do this at quite a few of our facilities. So when we run our tech metrics, once the facility's given us the approval, we actually update this on a routine basis for each person, depending on how well they are. So somebody does jump into, hey, we can let them go quicker, and then we see any kind of a dip in accuracy, back it right off of them, and it's something that we constantly update.
Yeah, and again, every LDAR contract has something like this. They're not all as transparent, but this is actually in a report that we provide to one of our larger clients. not Chevron. I do something similar. Go ahead.
With a contractor, you monitor the time. How do you quantify if it's a contractor? Say, average should only take.
So we don't actually track the time for the repair attempts,
Okay.
right? So for the repair attempts, there's nothing built into the database, so, hey, it needs to take this long, because, there are just so many variables in there. I mean, does the technician carry his wrenches in his backpack? Does he keep them in his pocket or a tool belt, right? That can have that's like a minute change just based off of that alone. And, and then certain valves, you don't want to set like a minimum or even say a minimum is acceptable, because just the ergonomics of where the packing is, where the bolts are, right? There's some out there that, like, if we said, hey, anything where they spend 5 minutes or on the first attempt should be good. I know a lot of valves I can go out there and look at, and I'm like, yeah, it's going to take me 5 minutes to make a half a turn on that bolt, because just the general ergonomics are where I'm putting my wrench. It's just such a tight space where I'm turning it like a centimeter at a time. So yeah, that part we don't really factor in too much, and it's kind of, we work with the supervisor and then that specific site knowledge to kind of gauge that.
And in this particular example, I mean, this client, I mean, this is, kind of a pretty big report we do for them. But they like to know that, okay, these guys in the red, what did y'all do, with these guys? Did y'all talk to them? It's usually some kind of additional training or, something to that effect. I mean, if they're in the red too much, then, and we actually find leaks behind them, obviously we're going to write them up and do a progressive disciplinary. The idea is not necessarily to get rid of these people. The idea is to make them better, to where they can meet our standards.
And sometimes, like we talked about earlier, we might have somebody in the red because, hey, that unit, they just got a new maintenance staff, right? And that new maintenance staff is on their game, right? We had one facility that during COVID, actually they had, they were separating people out. So they actually had an intensive preventative maintenance facilities, trying to minimize the number of leaks. So they literally had 2 groups going around just kind of snugging up and checking almost all the valves in their facility. And we saw in our monitoring event, it looked like we found way less leaks than what we did. But we got, when we confirmed that was the information, and we did audits. Obviously, we did comparative audits to make sure we didn't miss anything. And once that was done, it kind of showed us that. But the next time through in that unit, we see that steady improvement, and we see those technicians, their scores improve. So the key is, it's not like, hey, somebody they scored low once. It's, hey, it's that. If they're consistently low, even if we're finding, an issue here or there, or like a reason why it was low here or there, it will still set off a red flag, right? There's not always, no site is improving their maintenance quarter to quarter, right? That's a long term. But it will show that, and then we'll see their scores pick back up to prove that. So we're tracking the individuals like Andrew was just showing. It lets us see that tracking where a constant improvement. So if it is a low point, it's just a one-time, right? And then you see them go back into the. Now, if we see 6 months straight in the red, that's a good sign to us that, hey, there's a problem that either A, we've already identified, we've tried to correct, and it's not working, or B, hey, even if we thought there was a reason these last few months, we're missing something and we need to look a little bit at there.
I'm going to try to move along a little bit. I want to save enough time at the end because I do want to talk about some of the new rules and the reasons behind those. So we have at least one module that Aaron's going to do.
Okay.
So other uses of predictive analytics, You can do like selective monitoring. We already kind of do that based on units. If units are over a certain level of leak rate, then you're required to monitor them more frequently. You could do that with specific attributes on components as well. Instead of grouping them into units, you could group them into all the components that are bigger than 6 inches. Monitor those monthly, where everything else, you monitor less often. Certain operating conditions that predict upsets and flaring events, you could get ahead of the game that way as well. And I'm sure people are already doing that. Let's see. This was the predictive leak modeling study we did. And the idea, was to look at a group of 1,000 components, look at all the different attributes, including the make, who made the component. And then put that, through an algorithm, we flagged all the high leakers and all the low leakers. Here's some of the things we looked at: monitoring data, vibration, valve condition size. The valve condition was a big deal. The manufacturer was also a really big deal. So some of these manufacturers, they sell their stuff cheap, and you kind of get what you pay for, I guess. The size was a factor, but if you were able to group them based on the high attributes, you would be able to get by with half the monitoring, and then still getting the same number of leaks. So this kind of gets a little bit more into the weeds of the actual study that was funded by the EPA. Well, it wasn't funded by the EPA, it was funded by a company who had to do it because the EPA had them do it, made them do it. Anyway, the pressure temperature didn't seem to be reliable determinants, but this isn't the temperature differences, throughout the year. It's like just differences between different components. I thought vibration would make a bigger difference than it did. It didn't. But the big things was the manufacturer. And then, I mean, if you look at a valve, you should be able to tell if it's a ratty looking valve. Auditors do this all the time. They have a selective bias to where when they say they're monitoring random every third component, but they see a ratty component they can't resist, they're going to monitor it. It's like, man, that group of components you selected to monitor yielded a 3% leak rate. That's, historically, where our company leak rate is, like a 1 or 1.5. That's pretty good, man.
Yeah, and just so everybody, there is no auditor unless they have a set group of. Here in the Houston area, you have HRBOC, they make them print out the exact tag number. No auditor's random selection in the field is ever, they see a leak tag, or a piece of a leak tag that's been removed, that one's going randomly. Valve that looks dirty, going to be randomly, which, through it is the analysis is all the other conditions, manufacturer, vibration, everything. And it's still one of the best indicators of something leaking. It looks like it's leaking. There's a good chance that it's leaking.
Yeah, and some of the newer regulations allow you to group components, how you choose. They don't necessarily have to be in the same unit. You can find certain attributes, like all these components that were built by this company called Benelli. Maybe we need to look at these components a little more often because they seem to leak a little bit more than everything else. So some of the newer regs, some of the uniform standard allows you to actually do that.
And even some of the old regs like BD, BDA, all it states is you must monitor them in the first month of a quarter, and you can subdivide them into groups as long as they're monitored, every 3 months. It doesn't say you have to subdivide by unit. It states that you subdivide them as long as they're months. Most places obviously choose to separate them by units because that's by far what you track of. But there is no limitation to what you can subdivide them by. As long as they meet that specific criteria, subdivide them in that group.
Okay, so I'm going to jump over to a kind of a real world example how we put a lot of this stuff together in at this one particular place that I'm talking about here. So over a period of months, there were elevated readings on their fence line study. They called in a company to come in and help them pinpoint where these leaks were. Unfortunately, the company wasn't us, but we did work with the company. They had one of the better systems that was able to really get the real time data in a van similar to this van. Although they weren't using a van, they were using an old broken down Toyota. So it had like a $6,000 RAV4 with a $80,000 piece of monitoring equipment they were driving around with. Or maybe more than that.
It's more than 80 grand.
Yeah, it's like, I think it's like 100.
It's like 180 grand.
Yeah.
Mass spectrometer.
Yeah, mass spectrometer. It was a wonderful tool. And anyway, we helped them. We provided the labor. I was one of them. I had the camera, and another lady had the tech. I had the Method 21. We were able to actually come down and the leak was actually happening. We're getting that reading along that road right there. The wind was blowing pretty steadily out of the southwest, which is the predominant wind anyway. But anyway, we were getting a reading around 6 ppb, 10 ppb out there on that road. So we started looking at in that area. On the other road right below that, we weren't getting anything, so we knew it was coming from that vicinity. We went in there with actual with the camera, and again, the wind was probably, predominant wind that day was 15, 20. So you can imagine along that around the side of that tall tank was probably more like 30, 35, 40. But with Method 21, we were able to find that leak. It was 5,000 ppm. And I apologize in advance because since I did the math, I feel like I want to include it. So using the Gaussian dispersion formula, I was able to reverse engineer the leak. Or it actually matched up to what we expected at the road. So the reading that we got at the road, when we plugged the 15,000 ppm into a dispersion formula, we're actually able to say, okay, yeah, we would have expected to get a 10, 15 ppm leak at this distance, which is about 150 meters from the leak source.
And with the combination of all those things, the leak was on something that did not require any kind of a leak. Right? It was a connector, and there were connector monitoring requirements out there. But there was a fence line hit. But didn't know where it was coming from. All you knew on the fence line is sometime in the last 2 weeks they had got something in the fence line. So there was the mobile van that was able to determine, hey, there is a plume in this general area. And then we were able, from that area with the flare camera, able to trace it back to the individual components where Andrew saw some actual vapors. He couldn't see exactly because it was windy, but he could see the general area where he could see vapors. And he's like, I'm seeing something in this area. And then Method 21 was used to quantify and identify the exact source. So it's really just, it kind of shows that there's no one thing that captures everything. It solves all your problems, right? It wouldn't be required to be monitored with routine Method 21. With the fence line, you didn't really know where it was coming from. With the mobile vehicle, you knew your plume was this general area, but you didn't know what to fix. But when you combine all the existing technologies together that are out there, you're not only able to find, know that there is a leak, but you're able to find exactly where it is, get somebody out there, get it fixed, and stop it from the atmosphere.
Yeah, which is my hope of where it's going. I think we can tell whether a unit's leaking by monitoring outside the unit, and then we can pinpoint where that leak is coming from. Then we can just go in and fix it. We should not have to monitor every component that's not leaking all the time. I'm not going to name any names, but I know the guy who owns that Toyota. He actually worked. His daughter works for you guys, for Chevron, in the environmental department. We'll talk later. But anyway, he's a great guy. He's on the right track with this technology. So yeah, I'm just talking here about what I just spoke about. What we just did. But yeah, I think there's, I've heard of a couple other companies who are doing like some permanent fixtures that are detecting leaks within units that are always on. It's like a SIMS, but it's like they're all inside. And I know they've gotten the green light to do that. And I think this is a study they've done down in Corpus Christi. But yeah, similar to that, when they get a hit on these small units, they can send a small task force in there to find out exactly where the leak is coming from, eliminate it, and then that's basically telling them that they have a leak-free unit if they're not getting any hits. So so does anybody have any questions on any of that stuff? Because we're about to move on to the next module. I think we need to take a break. 5-10 minutes. And this is going to be.
Oh, that's the water demo.
Yeah.
Okay. Yeah. So yeah, one piggyback from the break, just so y'all know what we're covering. It's kind of audit preps, what to expect at different steps of the audit, what to do when something goes wrong. But I know everybody, when we took the last break, just in case anybody had stepped out before, mention if there what is a sign-in sheet up here if y'all need to sign in. If you leave your email address on there too, we'll forward you over a copy of the presentation, and that way you can have it for your training records if this is your annual training. Like a CD, required LDAR annual training. We don't have any down in Point Comfort, but we got one down in Point Comfort. Right there, and I know there's
Oh, we have some down there.
I don't think that we haven't been there. We haven't talked. We not talked to them down there. Their inspection down there.
Oh, Eric is supposed to be with us.
No, I don't think. Oh, he might be here. I wasn't sure. Oh, yeah, I know we're not. I know we're not. Afternoon. They're up here too.
Yeah, the Techmetric's been a big deal at Formosa. The Techmetric we implemented, it's been kind of a big deal down there.
We do have power. We only have one. Took a while. So.
Yeah, that's which if it's in that 5,000, you should be able to see it in. I'm guessing probably ethylene based compressor house.
Well, and that,
if it's in a compressor house.
yeah, if you can eliminate the wind in that example, I couldn't see that leak that she found at 5,000 ppm. If it was not a windy condition, I would expect that leak to probably be more like a 15,000 ppm leak. But she was able to find it in method 21, but I couldn't see it with the camera.
So you got 65. You got a wind. Oh, I don't know what that's going on there.
So there was.
Yeah. Tracking down stuff. Now it does typically need to be a bigger lease, but you're 250 to 300 ppm. They're not saying all.
I would say the average cost is $2 to $4 per component for monitoring.
Oh, no.
Or a DTM complaint.
You guys know.
Difficult to monitor. I think in that example, I was looking at where they have to carry a ladder around and they're only able to get like 50 or 100 components a day or something like that. Well, typically, Yeah, typically it's usually like 60 cents, something like that.
Right now, we're still waiting to see what the verdict's
Yeah. Yeah, that's in the ballpark. We don't do per component anymore. We'll either do a lump sum or we do a hourly. The per component, I work for companies who use per components and who do that kind of pricing.
If that's all you do for a first repair.
It kind of, it encourages the technician to get more done in a day than, may not always be good for them to do, I guess. No, I mean, it's been so long since I've been in a position where I had to, actually write out bids. But yeah, from what I remember, 60, 80 cents is, I know some places, well, inflation is really, we've had to go back and say, hey, we got to pay our guys more now because we can't keep people anymore. And all that new FLIR stuff coming out, we're going to be paying technicians, like $25 an hour. Just so we can have enough. So all that's going to get, unfortunately, passed on to, this is how much it's going to cost for us to be able to do your work.
I'm on my Friday, Saturday, Sunday off, and be checking on my Thursday afternoon at 4 o'clock, and then Maria sent me an email to me Friday morning. Not getting looked at again until Monday. One of those deals. Which, so we're fortunate that you got that for somebody. But at the same time.
Yeah, Tom.
Oh, yeah. Sure. Yeah, it's just you're finally getting the price.
If we're not allowed to have
A lot of it is just like around animals. Or if we affect each other now.
Yeah, I don't. It's also, at the time,
Actually, 1,000 people in the second.
Yeah, you know,
You grab that guy and go, hey, let's go look at this, and change it.
Oh, yeah, yeah, definitely.
How about your experience at GDR with the first time, we got a lot of.
Yeah, so with the tech matrix, the biggest pushback that I always get are the people that are doing the rechecks and monthlies, right? When we first implemented it somewhere, everybody's like, well, he's doing rechecks and monthlies, it's gotta be right. And every time that I've seen somebody wrong, it's, hey, they're getting a lot of 350s when they should have been up over 500. And we would expect it to be over 500. And when we do the auditing, it was over 500, right? And it's one of those, it takes the difference out of, people, you've seen them do a good job for like years and years and years. And then they're slipping a little bit because they're complacent. And everybody, have years of evidence that this person knows they're doing a good job. And it lets us see it in a data standpoint. Hey, they're not doing as good as they used to be, whether it's complacency or whatever it may be. And it flags it. The people that have been doing the same thing for a while, you can actually see when it's at it. And every time I put, oh no, this has to be, but right now, it's 5 out of every 6 days are wasn't approved. Whether it's something minor, 80, and if they would have sat on it at a different total at 520. Could be something minor like, but yeah, 5 out of every 6. I did everything in about 50% of the place. That's the most. Whatever that issue is, they go from having that's a single swing. Has a negative score. Yeah, the score that makes.
Yeah, well, the guy who had the Toyota, Ken Garing.
Oh. Yeah. Yeah, yeah.
Is he Colorado? He drove that little, yeah, he drove that RAV4 down to Texas City. Yeah.
I like the mobile.
I want to say that the mass spectrometer he had was a famous. I don't know where he got it from, but I mean, I priced them out. They're like, yeah, they're, I'll say a little over 100,000, 120. But this stuff, he had almost like a vacuum cleaner size too. He was constantly sucking stuff in, and he had a nice readout that would tell him, immediately when he was getting it. So it worked. I'll say, I mean, I'll just call it what it is. It was a lot better than the system that I had developed. Well, I spend more money on my vehicle because I don't want to be rolling around in a RAV4. Yeah, nothing on. Yeah. His budget was like 150, 140,000 on equipment. I had probably about a $300,000 budget or something. For the van, I think we ended up spending about 275. It was like, we had 2 GCs in there, they were like 35,000 a piece, and we had some fancy calibration equipment and different stuff. Database, I mean, I could access this van from anywhere and start my calibration process, before I ever got to the van. But if I could have had that Dumas mass spectrometer,
Oh, yeah, the mass spectrometer.
I looked at him too, and the guy I was working with, he was like, I think it's because that's all he knew was GC.
He's a GC guy, so.
Yeah, so he wanted to do GCs. I mean, I looked at it like, don't you think these mass spectrometers are pretty clear? Yeah, but let's do this. Unfortunately, I mean, when you don't have anybody preceding, you don't really.
Yeah.
There's no precedent, so. Yeah, if you went with this and you went with crater, I mean, it's on you.
Yeah. All right. Most people are back in. I think most are back in, so I will apologize when I'm going through these next ones. I'm not the best at following the slides in order. Sometimes I get a little bit ahead, so you might see me skip through some of them a little quickly. But kind of what I'm going to talk about the next section, it's just really about what to do before audits, during audits, whether it's a third party, an agency audit, what to do if something is found during an audit, right? Because, I mean, we all want nothing to ever be found, but eventually somewhere, whether it's somewhere you're currently at, or you may move to go do something new right after something was found, it does happen around the country. So knowing what steps to do and being prepared is kind of key in those situations, right? So what's called one of the key things to make sure we're doing, like for any audits, is you always want to make sure you're trying to audit proof your program, right? You should always be prepared for an audit at any moment, right? It shouldn't make a difference whether an auditor steps out there today, or if they give you a week's notice, a month's notice, and it's planned and scheduled. You should always be ready. But regardless, even though you're always should be ready, any prepped audit or any audit that even if it's a few days in advance, there are certain things that you should always do. What's another thing that's not often talked about enough is actually, what to do when a mistake is found during an audit, right? People don't talk about it too much because, quite frankly, when something is found, you're not allowed to talk about stuff if there's any kind of a litigation. So I'm not going to have any kind of specifics or anything in here, but a key thing is actually getting that industry information, because no matter what you're going through right now or what audit issues you have, somebody has already went through those issues in the past, right? You're typically not the first one with a specific issue that's coming up. You may be the first one, maybe the first oil and gas plant that's getting hit with a version of a consent decree or something after an audit has happened. But whatever issues they've had, somebody else has already went through them, and it's not really talked about enough. And when you communicate with other people in the industry, or you talk to people that's gone through it, there's a lot of things that you wouldn't have thought about that, they may have thought about too late in their process, or that came up in their process that helped them out a lot. Okay. We all know the key reasons why it's not talked about. It's simply because if you're going through litigation, you got to minimize your risk, right? Any communications, they could all be used against you in the future, or come back, potentially as an issue. One single misunderstanding when you're communicating with the agency could result in, several thousands of dollars worth of additional fines that are put on there just because something was communicated poorly, right? Doesn't mean that it was an actual issue. It just means the communication of what was going on cost a lot of money. And then nobody knows that you had a way out of it, or you weren't out of compliance until after the fact, when the fine's already agreed upon, it's already being paid and everything's already settled. And at that point, costs more to go back and do anything. You know, lawyers are expensive, right? I mean, consultants, you know, whoever you're paying, all the personnel's manpower that's spent on these activities, that all has an inherent cost too, right? So sometimes it is just cheaper to, okay, we messed up there. It's too expensive to go back and try to update that. What's called, when you're dealing with lawyers too, right? What's called, when you're doing that, a lot of people, they want to compartmentalize that information, right? When you do that, you lose the insight, right? If you're talking to somebody when you're going through, you know, potential negotiations with the EPA, right? We work with several gas plants around the country. We had one that we started working with they called us in to help them in the middle of their consent decree negotiations, right? If they would not have called us in or reached out to other gas plants that had had consent decrees in the past, there were quite a few items that they were trying to add into their consent decree that other people had, when they tried to add it into theirs, had already successfully said, hey, this doesn't provide a true environmental benefit. You're just doing this to make us spend more money to, you know, to upgrade certain types of equipment, right? It's not actually limiting our emissions. We don't have any deficiencies here. You're just writing this in. And other people had already successfully made those arguments. And up until the point where they brought in outside help that actually dealt with others, they hadn't reached out to any other facilities that went through that same process. They hadn't worked with anybody that actually had went through that process. It was all being handled internally. And there's vast amounts of information out there. No one person knows everything, right? And there are plans that other people have successfully completed during those processes that what's called, you just don't know if you just pretty much close the gaps and keep everything internal and don't reach out for, you know, might not be specifically help, but just insight, or ask a question. It's like, hey, have you seen this before? Have you heard about this? What would you, you know, do you think this is doable? Right? What's called, there are a lot of people out there. I've done it. I used to do this presentation with somebody by the name of Brian Whitley. We worked together for a little bit over a decade. And we've done several projects with the DOJ, with the EPA. Andrew spoke about, you know, collecting the data for the predictive analytics that they submitted as part of, you know, an EPA required project. We've done that. And there are other people out there that have done those portions, that when you're in those negotiations and you're doing something with the EPA or with your state agencies, they have the insights, you know, they've actually been on the other side and actually know what they're thinking about, right? How they're approaching it. Because I've been in several situations where I've heard, you know, somebody think that the EPA was wanting them to do one thing, or specifically trying to have something be done. It wasn't really their intention. They were just approaching it from an angle because they knew they were going to get pushback and there was something less that they wanted. And it completely shut down negotiations and took the two sides a long time to come back together, when it was as simple as like, hey, they're looking for something like this. If you agree to something minor like this, they're going to drop all that big stuff, right? And just because they didn't know exactly how they were thinking, it just completely halted a process and ended up costing thousands and thousands of extra dollars, and, you know, time preparing stuff for the EPA, meetings, communications, travels to and from DC. It just, you know, just by not understanding what they're looking for and being able to have a conversation or ask a simple question that could, you know, completely negate the need for a whole nother like issue where you're arguing and you're never going to come to eye, where they're asking you to spend, tens of millions of dollars to do something that has no benefit. And like I was saying, sharing of the information between people that have actually been through those situations before. I'm sure several of y'all in here have actually dealt with the EPA on these specific issues, or dealt with your state agencies, dealt with a local administration or something, dealt with a third-party auditor, however it may be. That sharing of information of, hey, this is what we saw when we were in the information, whether it's from one company to another or internally within your organizations. You might have faced it at a facility in Texas that now they're talking to people in, California or Illinois about the same type of thing, right? That sharing of information is probably the biggest asset and the biggest key that could be for any audit or any negotiation. Because like I said, you're probably not the first person in this situation. If you reach out, talk to other people in the industry, you don't have to give specifics. Obviously, most data in these situations is going to be privileged and confidential. So you can't really give specifics, but there is somebody, if you talk about it vaguely without complete details, that's probably already went through it, they can give you some insight where they can actually help you out in these situations and prevent some potential pitfalls. What's called, one of the things that we always talk about is like actually minimizing the items in the book. And by the book, we mean what they are writing down out in the field while they are there. Like during an audit, if somebody from the EPA or somebody from your state agency is actually writing something down while they're out in the field, that's a potential finding. You want to minimize that as much as possible. They're not just, if they ask a general question and you see them take a note, they're not going to forget about what they're asking about, right? They're going through, they're compiling all their notes, they're compiling their questions. The key is if it's something possible to answer right then, you want to answer that question right then to keep it off the list. Delaying the information or delaying an answer, saying, I'll get back to you with it, right? That's something they'll add those items in there. When they add the items in there, the more items that are in that book at the end of the audit, the more things that you're going to be paying, people to dispute later. When it's something that you could just spend, even if you can't answer it right there when you're in the field, you can get somebody else to go get that answer. Get that answer before they leave the site. Take it completely off their list. You don't want to leave it for the attorneys to battle later, as long as you can answer. There are going to be a few things occasionally that you might not be able to give the answer for, right? But there are quite a few instances where I have seen, and I've stepped into negotiations where they were just waiting to see some form of a documentation, something as simple as precision calibrations that just were not given to them at the time of the audit, right? Or while they were on site. Something small like that became something that I sat in meetings for 10 to 15 hours when we were brought in to help, just talking about those issues because it wasn't presented to them at the time of the audit. And it started raising questions when, if somebody would have just sent an email or ran to an office on the other side of the plant, they could have just pulled the book, showed it to them, and it would have been off the list right there. So minimizing what they have in the book is key, right? Having a good closeout meeting, right? At the end of each day, if an auditor is there, you should always request, hey, can we have a quick closeout meeting where we can discuss any issues or concerns that you have, right? And if they bring stuff up during that thing, the goal should be, let's have those answered by the time we meet with them tomorrow, right? If they're saying, hey, I'm wondering about a certain piece of equipment, say they're out there with a flare camera, right? And they see a tank venting. They look at your tank vent, they see it venting. And their concern is like, yeah, we saw this tank venting, and they just notate it. It's a quick flyby thing when they're going through it, right? If when they show up in the morning, you can say, hey, this tank was actively loading at this time. that is designed to vent, it's captured in our tank emissions, boom, you got it off the list, right? But if you don't provide them that information and it's just a comment during the closeout item, you don't hear about it again potentially until they're actually sending you a notice of violation or they're sending you an issue saying that something was wrong, right? When it's something that can easily be proved, you're already calculating those emissions. It's doing what it's designed to do. There's nothing wrong with it. But if you don't give them that answer when it's a clear-cut answer, now obviously you don't want to try to BS them and give them some BS information, but if you can get the answer, getting it out of their book and minimizing it is key. And that end of the day closeout meeting is probably the most important part of the audit besides being prepared for it before it happens, right? Because you don't know what if you just let them come in, do everything, make a bunch of notes and leave, you don't know what questions you're going to be answering later. Okay. What's called anything that they find, they're going to write down, right? They will not forget about anything. And ask them for clarification. If they're writing something down and they're just saying, oh, I just observed this, ask them, okay, is there an issue? Is there something you see wrong with it? It could tell you how they're looking at it, right? You might not think it's an issue, right? But they could be looking at it from a completely different standpoint than what you're actually out there to do, right? So asking those clarification questions, lets you know what strategy they're approaching everything from. So the next thing, there's going to be 3 slides. I'm going to go through these really, really quick. It's really theories about how you treat the auditor when they're doing comparative monitoring tests out there, right? So there's 3 theories. The first one is you verify everything they find. If you know there's an agency, if there is an agency person out there, you should have somebody out there with a TVA as well to verify everything they find as they find it. The other possible way to go about it is ask to see them drift their machine. If you ask them to see them drift their machine and their machine fails, it does negate anything that they found, but it will not make that auditor very happy with you, right? So if you're dealing with an agency person and you ask that to happen, they're going to be looking 10 times as hard when they go back out there to check it, right? And they're going to be, if they don't find anything when they go back out and check the same leaks they found, they're going to think that you went out there and fixed it between them. So it's not really a good thing to do. The other thing is I've seen people after an auditor checked everything, instantly asked to see a agency auditor's precision calibration information. Like asked to see if that machine had a valid precision on it, right? That is just going to cause them to come back more aggressively and try to hit you twice as hard on everything. Because if they don't, either A, they're going to supply it to you and they have it, which they should have it. They are required to do it the same as we are. But if they don't have it, or even if they do have it, they're going to be not very happy and they're going to think you're trying to find loopholes to get out of stuff. If you do what we talked about at the first, right? If you have a TVA and you're out there and you're confirming the leaks as they find them, the other 2 are kind of moot points. You have your confirmation. If you're not finding a leak and they are finding a leak, then you can dispute it right then. You can be like, hey, I'm not finding this leak. And they can see you and watch and confirm that it's not being found. And I've had auditors take off leaks because we could only get them at 400 ppm and they couldn't repeat it right afterwards either. So you can get off leaks that way too, right? What's called the stuff that you do confirm, for a fact it truly is leaking, right? You've confirmed it. You already have your information. You put it in your database. You can start your repair process right away. So when it comes up later, you're already following your normal process. You're getting it fixed as soon as possible. When you're observing this, you do need to make sure you're taking notes of any of those discrepancies, because when you do have those discrepancies, they're going to be questioned later, right? Or you need to always assume that they will be questioned later. And when you can confirm everything and you're able to get that just not leaking, you do have a sense of control, right? When you're in control of that because you're showing that it's not leaking. And then now when you ask about a drift, or if you ask something at the end of the day of that, you're not saying it where in a manner of, I'm trying to get out of this leak, or I'm trying to say, hey, this wasn't happening. You're saying, hey, our machines are reading differently. Let's both drift them and see which one's right, right? There's an easy way to approach that without making, somebody angry about you asking for that confirmation, because you have evidence, hey, your machines are reading differently. One of them is not working properly. That's pretty much kind of what we're talking about, the same thing. The other thing is knowing who the people you want to have involved when these audits happen, right? Everybody should know who is the go-to person when an auditor shows up, right? If you get a phone call saying the EPA is going to be on your site 2 days from now, who do you want out there as support with you? Whether it's internal, an external person, who is that person, right? We have dealt with a lot of programs, right? If they tell you they're going to be out there 2 days before an audit, right? If I get that phone call at a facility that we're at, and I hear, hey, the EPA is going to be out here 2 days from now, I'm spinning round the clock. We're having people on those sites. We are walking through. We need to make sure there are no low-hanging fruits. We should always be ready, right? But we're in a facility that changes from day to day, right? So we got to double check for all that low-hanging fruit, right? I think. So you got to look for all that low-hanging fruit, and you work round the clock before the audit to do it. Because if you don't do it before the audit, it's going to come up during the audit, and you're going to be working round the clock for weeks afterwards trying to justify everything that happens, right? So it's better to spend that time before the audit making sure that that low-hanging fruit of something that just changed out there, hey, an operator just took a sample yesterday and he forgot to put the plug back in. He closed the valves, but he forgot to put the plug back in, right? Hey, this valve is double blocked, right? It's not an open inlet line, but some scaffold builder walking through the unit accidentally bumped one of the valves with his legs, and now one of the two is partially open, causing a potential deviation, right? And if you walk through the units and you catch that before the auditor's there, it's something minor. You tap a handle up, right? You're not fixing end of the world problems, right? If you don't have a good program where you're ready for the audits in advance, you're not going to be able to fix that overnight. But you can fix all those low-hanging fruits where if you do have a good program, it doesn't make your good program look like a bad program. Because I have seen a couple good programs that have got hammered by agencies for open inlet lines just because of something that happened 2 days before the audit, right? It was the last 2 days. 99% of the year, they have almost zero open inlet lines in their facility. Their operators are great at putting everything in. One round of samples, somebody just didn't close double blocks. You never see it before that. You never saw it afterward, but you ended up seeing that, and they got hammered during an audit because they just didn't do the pre-work beforehand, right? And that's something you have to make sure. You do what's called, once the audit has ended, once they've walked in the door, that auditor is starting to write a story, whether it's a story of your program being good or a story of your program being bad. He is writing that story the second he steps foot on site. Sometimes he's writing it before he gets to your site. He's writing it as soon as he starts looking at the data. The key is you don't need to assume what happens. You need to try to take control, make sure you can guide it. If they have something, you can trust it, but you have to verify. And everything you do out in the field always has verifications. Andrew will tell you probably the phrase that he has heard me say the most in my life, whether it's talking about, one of our managers, a supervisor, a technician, anybody that works for us, is trust but verify, right? I trust all of our people, but without the verification, that trust means nothing. Okay. when you're working with these auditors, a cooperative move goes a long way, but you have to be inquisitive as they're doing stuff. A simple thing is just eating lunch at the same place, right? You're not you're not going to be able to buy the EPA auditor lunch, right? He gets $100 a year from everywhere of stuff that he might be able to accept for like a snack or something here or there, right? So you're not going to be able to buy him lunch, but go eat lunch at the same place so you can just communicate. You ain't got to talk about that, but just communicate and you will get an insight into what they're actually looking for, right? What's called, if they are saying something that does not seem right, their interpretation is not law, right? All because they say you can't do something or something's wrong does not mean it's really wrong, right? Consistency is key, both on their side and your side, right? If you have a written LDAR plan, right? I saw a facility get out of they had about 10 opening line issues that were found in a facility, right? They got out of all of them because of their written plan. What it showed they would do before it was claimed was consistent and it was consistently followed, right? Even though that plug wasn't in there and it hadn't been in there for it, in their words, they said it was about 3-4 hours, right? But they had a plan, they had evidence that they were following that plan where any time they pulled a sample, they would have it plugged within, I think they actually notated within 12 hours in their plan. And they were able to prove that, hey, they had somebody verify them all being plugged in that time frame and that they followed it, right? And that consistency and actually have it written down and following that consistency saved an auditor's interpretation, right? And I've seen an agency person tell two different plants, same person said two different things to two different plants about, what they were allowed to do. His inconsistency has made, his interpretation is not valid. If we can prove it in black and white, we just have to follow the black and white. Right. And when we're telling the story, we also got to remember who you're telling the story to, right? Why it's good to get to know and be cooperative and like actually talk to your auditors, because different auditors are looking for different things, right? So when you're filling out, when you're talking and giving responses, the person you're delivering them to matters, right? I will definitely deliver my responses differently to that I know about the TCQ and the EPA, the people that I've dealt with the most. I can give them the same information, but I have to present it in a different manner, right? They're not the same people. When you know this, an audit is coming and it's going to be done, it's time. You got to kind of circle the wagons, right? So from the moment they leave there over the next 6 months, anything that they have made note of, even if they haven't reached back out to you, you need to be prepared for every single possible way they can come at you with the argument, right? Most facilities, especially what's called get hit like in LDAR events. These are the typical low-hanging fruits that they look at for, right? And these are the things that they add in all of your consent decrees. These aren't the most common findings. I mean, OELs is a common finding at facilities around the country. It's getting better and better. I mean, when I started in the industry 18 years ago, I could walk out into a unit, even though it had the same requirements now, and I would see 25 OELs in the plant that I was at just during my routine day. Now, if you see one or two, it's a big deal. Like everybody, when you find it, they're looking, it's like, no, there can't be an OEL out there, right? They, even operations themselves, they don't believe that, until they see it, they're like, no, we plug everything, right? Whereas 20 years ago, it's like, oh yeah, that's no big deal, yeah, I forgot to put the plug in. And it was just normal back then. Now it's not normal, but it is still one of the most common agency findings. But if they're showing up, these things, we know they're going to look at every one of these items every single time. And these are the low hanging fruits that you just have to make sure that if you have any issues in any one of these areas, you need to know about it before then. An auditor should never find something that you are not already aware of and already reporting yourself, right? So if they see new equipment out there, it should be something added within the last 30 days, which you have in your process, and you can show them an MOC process of how you're going to capture that, right? If it's new equipment that's been out there for 6 months, that should never be there for when the auditor gets there. If you're given advance notice, there should be that walkthrough where you can actually identify. What's called, once everything has been done and you're replying to them, you got to review everything in detail and close all holes. If you identify a hole is open when you're doing it, get it closed, get it prepared. That way, when you send your response or when they show up, whichever one it may be, you already have everything taken care of. What's called, when you work with the attorneys, that you have to have the strategy going into these meetings, right? You have to make sure, if you know something, even if the agency hasn't mentioned it to the attorney, right? You have to make sure everybody is aware of everything. No detail is too small. It doesn't matter what it is. You have to supply all the details to everybody. When they're going through in these situations, there is nothing that should be left out. The only thing, when you're working, like the experts, attorneys, yourself, we can prepare strategies, fix everything, have a prepared plan to go in. But if something comes up that somebody knew about, that an attorney didn't know to prepare a plan for, everything falls apart as soon as that happens. So no detail is too small. I say bring up everything when you're having those internal discussions beforehand. And you still stay relevant to the situation. So make sure you're not talking about something that happened at some other facility or something that you've seen 20 years ago. It's details about the situations that you're in currently. Okay. This is just, I think we've talked about seeing the whole picture and being prepared and prepping for these plenty of times. Got to also be aware of smoking guns, right? A lot of people in here, I know we're talking about LDAR today, and we've talked about a few other things, but one thing to remember is most LDAR consent decrees aren't really, you're not necessarily in an LDAR consent decree because of an LDAR issue, right? There was something minor in an LDAR program or minor in another program. If you have multiple things covered by these, there was a minor issue, and then there was that smoking gun in some completely other program. Whether it's, hey, got a whole, rusted tank that's leaking crazy, a stack that is way out of compliance, there's usually that smoking gun. If you're not aware of what the smoking gun is potentially, and you're not already in works and have that reporting and stuff, it doesn't matter how well you do everything else. You can keep everything else minor, right? But if you have that smoking gun out there that you're not aware of that comes up during these audits, it pretty much takes your power away to argue anything that they find during the audit, right? A minor one OEL turns into a major problem if you got a stack that's emitting, that they see heavy particles coming from that you're not reporting anything from, right? If you have a heater that they're walking out there and nothing's leaking, and then there is gas, there's a natural gas leak out of the side of the heater that's just pouring out, and you can't argue, you don't have many leaks, but they see tons of emissions from something that you're not required to check, right? If you have that smoking Gunn out there, you need to be aware of it. You need to make sure you're addressing it because it could make any minor issue that would just be a line item on a report. Hey, couple $100, couple, or $1,000, you're done with this whole thing. You're just paying for a single open-ended line into a full-fledged consent decree.
I want to add, I quit smoking about 15 years ago.
Smoking gun. Okay. I think just so everybody knows too, all because you settle on something doesn't necessarily mean you're wrong with it, right? Sometimes it is smarter to just do something small, right? And what's called, and just pay a single fine versus paying all the attorney fees and all the CD implementation. So all because something is settled, it doesn't mean you are doing something wrong. It just means sometimes it's cheaper, right? It's just cheaper. Why spend 10 times the amount of money, what's called, and have to do more work, right? Anytime that you have a facility that's negotiating any of these things, you need not only people that are experts in how you're going to do it and what it's going to be, you need to make sure that somebody is aware of the implementation cost of any requirements that come out of an ER, right? Because what may seem minor to somebody, when you look at the details and the actual implementation costs, it could be huge. So you got to make sure that you have somebody familiar with all facets of the implementation costs, not just, hey, can we do this? Or, are there people out there that can do this for us? There's multiple facets that come in there. If they're talking about upgrading a piece of equipment or an upgrade of a gasket, you got to have your operations involved where they know, hey, what equipment gets shut down with this? You got to have your mechanical people involved in, hey, what's the maintenance on this new gasket? How often does this change our turnaround schedule because we're having to replace something more often? So having somebody understand the implementation cost is definitely key. What's called, and when you're going through stuff, knowing the difference of a violation, right? If they call something missed method 21, but you got a reading for it, but you had a requirement for, every reading will have a time date stamp. There's a big difference between a missed inspection and a missed time date stamp. Those are two completely different things. So making sure that if you do have findings, that they are actually assigned properly, right? There's a difference between quasi-directive maintenance and directive maintenance in, certain permits, right? Making sure that the findings are clear and legitimate and they're classified properly. Because whatever you have, they're going to put that in your consent decree. And the cost of that, once it's in there for life. The stipulated penalties, things like that, they stay around forever. And then there's other things you can look at while you're in there, right? There's a give and take in these negotiations, right? Sometimes when you're talking about stuff, they want certain things done, but you can adjust it the other way. The EPA will say it's not about money, but we all know it is about money at the end of the day, right? Everybody wants to protect the environment on both sides, right? There is I'm sure everybody here I believe you could probably say your facility doesn't want to do harm to the environment. You want to mitigate as much as possible. There's always cost with everything. And the EPA, they want the same thing, but they also, let's be honest, they do want you to write a check. Right. At the end of the day, they do need you to write a check along with improving your environmental thing. So there are negotiations where you can make in there where you can offset certain things by maybe adding higher stipulated penalties to, reduce an inspection count, right? It holds you more accountable because it will cost you more money if you do it wrong. But what's called, you could save money by, not having as high of a frequency and checking it less often, even though you have that high standard to make sure you're doing it right. Because if you do it wrong, it'll cost you a lot more money. And when you're going through these, I guess this will be the last thing. I think The last few things that I have on here, we've talked about. So for the auditing, I don't think I need to hit them just because there's more slides. But in these processes, you should always have somebody playing devil's advocate for every one of your responses. If everybody in the room is in agreement and nobody's trying to say there is an issue with the response, you can miss something. If you should always have that devil's advocate in the room, and that should be the person's, their sole responsibility. Usually if you're working with attorneys, most of the time, that's what they do half the time with the responses that they're given, that's why they have multiple in the room, is they'll play devil's advocate with each other. But when we're thinking about it from an environmental standpoint, that devil's advocate person is a key, right? Sharing information and having somebody play devil's advocate for every solution that you put out there will put you in the best position for success in those negotiations, because any argument that comes up when you're dealing with the agencies, you've already had internally, right? You've already talked to somebody that's went through it. You closed all those gaps and all those holes in your program. Does anybody have any questions or anything that they've seen, any just generalized things, whether it's agency, third party, internal, how to do any part of it, what to look for? I think that's all I had on here, Andrew. I'll skip ahead to, or you can skip through the 900 pictures that we have.
Yeah, some of this was geared towards people who are, training for LDAR. So we would normally just line everybody up and just have them take turns pointing to where they would monitor, but I don't think we will skip that here. I mean, it's not too bad. Hoping by now everybody has figured out the word for today for Wordle. If not, I have it for you. You know what Wordle is? My wife is into it. And I help her out every now and then. Okay. No, it's after 4 o'clock, so I really just kind of wanted to talk about the first of it. I know we have one oil and gas person, Targa, right? May or may not affect you. I know a lot of these companies have upstream portions of their company who have to deal with the actual wells. So this is what we're talking about, the wells and the compressor stations, stuff like that. It's a new Quad OB and Quad OC. If anybody's already dealing with Quad OA, if you have areas that are not Quad OA yet, the Quad OB and C is going to take over that.
Which I'm gonna step out for a second, but just if y'all have anything to do with not applicable to anything, it's not official yet, but Quad OC, unlike all the other Quad O's, is applying to existing sources. Whereas all other NFPS rules, you have to trigger it. This is something that if you meet the standards, right, if you're that type of facility, would end up just automatically.
Yeah, it's going to affect everybody indirectly because we're all dealing with the same amount of resources, both manpower and equipment. So, y'all are asking about cameras. Cameras are going to get, and they're going to be in incredibly short supply in the near future. If they actually promulgate this, I mean, we're talking about 900,000 wells. And I don't know how many compressor stations, but I have a little bit of experience with this. As I alluded to before, we had a grant from the EPA where we built a van to do a study at Alabama Coshada Indian Reservation in East Texas. This is a typical wellhead. If you can see the bigger square on the bottom left. That's where the wellhead is. That's where my truck was parked when it was next to those that tankage. All those other little things are houses in the vicinity. The wind is typically from the southwest, especially during the April-May time frame. The thing that was happening, and you can see these I mean, you can imagine if you have like a lot of emissions coming up here, you know, from that particular spot at that time of day, it's going to flow into these housing areas. And there was, these guys were getting nosebleeds. They were, you know, getting sick, particularly around May for some reason. But I mean, we kind of figured it was because, you know, the tankage held the liquids, you know, during the winter time, and then whenever the sun, when it started getting warm in April or March, April, it would boil the liquids off, and it would come out. So I'm not talking about, you know, small amounts. Whenever you're standing next to these tanks, you're actually, you can see the fumes, you know, with the naked eye just going off and then going off for miles. So, I mean, it's not a major thing. And I mean, I always preface the discussion with this because you got these new rules that are regulating methane that was never regulated before. You always have this subset or, you know, group of people who, you know, they make all the, you know, most of the comments. So say, oh, you don't want the United States to be energy independent and all this stuff. But I'll tell you guys, in the lack of regulation, I mean, you get, you know, stuff like this. See if I can. Yeah, so I don't know if you can see that, if it's big enough or not. This other one. Look at the little spout coming off the top. You can see that's liquids coming off, and it may be a portion of it's water, but I can tell you all the grass around it was all dead. And whenever this stopped working correctly, somebody took this piece of equipment and they laid it on its side on a couple of railroad tracks so it would continue to produce. But this is, unfortunately, this was, you know, at these particular well sites. And I know the LLC that was controlling it wasn't any of the big name brand companies. It was LLC called White Horse LLC. And which is pretty typical also of all these older wellheads. They're all controlled by, you know, these companies who are, you know, they kind of hide behind all these firewalls so that if they get in trouble, then whoever owns them doesn't necessarily get in trouble. But this is just kind of like, you know, one minor example. Let's see. As I mentioned before, we were monitoring mostly for BTECs, benzene, toluene, ethylbenzene, and xylenes. Now, my particular setup couldn't capture all the methane and stuff like that. We weren't looking for it. We were looking for the stuff that would actually cause people to get sick. As I found out, you know, during this time and since then, apparently, so they have these glycol dehydrators, and you can see the equipment sitting back there behind it. You know, so the glycol dehydrators are designed to pull off as much water as possible. And they have the boilers that actually try to boil the water, and they get all the water out so they can reuse the glycol. Well, what also has an affinity for glycol, a lot of you probably already know this, is BTEX. So the BTEX gets entrained into the glycol, and then it gets boiled off with the water. A lot of the more fancier facilities have a BTEX you know, containment system that works with in conjunction with the glycol dehydrators. A lot of these older wellheads, they don't have anything like that. So basically what they do is they boil off the water, and they're also boiling off all those BTEX at the same time. So all of that gets entrained, it just goes to atmosphere. When we're monitoring with the dam, that equipment you can see back in the corner, there was at one point we were about 20 feet away from that equipment downwind, and we got some, I think the highest reading we got was like an 8,000 parts per billion hit right near some of this process equipment. So these high readings, again, it's just the BTEX. Every time we went out, when we were out here every month for a 2-year period, every time we went out, we at least got, you know, 200 parts per billion. We kind of got a smattering of 1,000, 2,000 parts per billion. But every time we went out, we always got hits around this old process equipment. So the basis behind this, so all of our data went back to the EPA, and then I'm sure there are a number of other studies that also went to the EPA. But the idea behind the new stuff is not only to capture the methane, but it's also to capture the VTEX and stuff like that you don't want to be anywhere around. I'm not saying that VTEX is that benzene is uncommon. It's not. Every time you go fill up your car, you're being exposed to benzene, probably around 5 or 10 parts per billion at least. If you're, mowing with a small engine or standing next to a generator, breathing in the fumes, you're probably breathing in about a 50 to 100 parts per billion. It's out there, but these homes were in an area where they were getting subject to these kinds of concentrations on a 24-hour basis. The other thing, I couldn't really bring any slides because of non-disclosure agreements and stuff like this, but I was going to kind of describe my time out in West Texas. I did some of our initial studies with the cameras on some of the older wellheads, so I could help write the SOPs for the process. So my experience, and again, this was another company who was probably close to bankruptcy. I think these particular wells were just acquired by a different company who could take better care of them. But at the time, I monitored them, and EPA's experience, what they claim in some of their background information was 1 out of 10 wellheads, the flares weren't lit. So it's basically just spewing out whatever is coming out of the ground, into the flare. My experience was 4 out of 10 were not lit during this. Then if that wasn't a kind of a big enough deal, and when I say they're not lit, I mean these flares are spewing out with a certain amount of force. I think a typical wellhead is around 800 pounds, and so these things were kicking out about 10, 12 feet. The size of the plume at about 10, 12 feet was roughly about 2 feet. So a lot of force coming out, a lot of nastiness. It's just coming out of the ground. They weren't trying to control it. And I don't know if I'm just an unlucky one who pulled the short straw to go look at this stuff, but from personal experience, that's what I saw. And then if that wasn't bad enough, the tankage, they have a common header going across these tanks. At the end of this header is called a Nardo valve. The Nardo valve allows air to, whenever the tanks are being emptied, allows the tanks to suck in air so that they don't implode. So while these Nardo valves, I don't know if they were messed up or what, but they're the same amount of force that I described that was coming out of these flare stacks was also coming out of the end of these common headers, where that Nardo valve is supposed to be kind of preventing that. So, and again, if you can imagine a plume coming out 10 feet, and at 10 feet, it may be about a foot diameter at that point, coming out of a 4-inch header. So a lot of force, and you can see it with the camera. You couldn't really see it too well with the naked eye, but with the camera, you can see it coming out there, and then you can see it going off for miles. Then if you just sit there and like, wow, to me, I was blown away, because you're seeing all the emissions that you prevented, and you try to help prevent in like a 20-year career, passing before your eyes in a period of an hour or a couple hours. So it was pretty bad. And then you look around, you scan the horizon, just to see, because in West Texas, everything's flat. You can see miles and miles. But you see these plumes. Like there's a plume, there's a plume. So it's not uncommon out there, and you can smell it. I mean, the sulfur in the air down there. I mean, it's just, when you go down into that basin, it just hangs. But anyway, I'm not an environmentalist by any standard. I have a hot rod. I do all the things everybody else does, but I mean, this was, in my opinion, it was somewhat egregious. And like I said, in the lack of any kind of regulation, I'm afraid this is kind of what happens. I mean, I go, my career goes back to when regulations, 22 years ago when their LDAR was, really, kind of taking hold, a lot of the chemical plants were getting in trouble. Before that, from what I hear, I remember, growing up, our parents had a certain car they would drive to the plant to work out of because, and they would keep the good cars in the garage because, the plant car would get eaten up, with acid from the plant. So anyway, I know a lot of you aren't going to be exposed to it, but everybody's going to be not hurt, but everybody's going to be competing with these resources. So all the information's out there, but we're talking about methane has 80 times warming impact of CO2 that's over a shorter lifespan. So basically it has a CO2 equivalent of, I think, 30 times. So the idea was that if they controlled the methane, they could make a bigger impact than any other thing because it does have a shorter lifespan. They can control it because it is easier to control. So basically, they're handing out a Quad A, similar to Quad A, but they're going to have a Quad B and a Quad C, and it's a lot more camera centric than the other ones. So they feel like the new technology that the cameras provide can yield the best bang per buck. The only problem is, whenever you do the math, they're thinking the number of wellheads that are going to end up being subject to regular monitoring is about 300,000. So these one of the key components are what they're calling, some of the new definitions of what fugitive emission components are. Before the pneumatic controllers weren't really included, they're going to do away with those. Control devices are now going to be fugitive emission components if they're not lit. So they have to be reported as a fugitive emission component. That to me is kind of a big deal. Whenever I reported your flares weren't lit, whenever I did that survey and I had to provide the data back to them, they said, well, these aren't fugitive emission components, so they're not within the scope of your thing. So we're not going to include them in our report because they're not leaks. So as we were saying, Quad B is new sources, Quad C is older sources. They're identical, except Quad C doesn't talk about certain like well site completions because it's not applicable because they're old sources. Most likely it's going to be every 6 months, either quarterly or every 6 months for wellheads that they're going to have to do an OGI. I'm sorry, I'm trying to get out of here because I know a lot of you want to not hear me talk. So the main requirements are going to require you to use this, what is called Appendix K. Appendix K is the new Method 21. All the regulations that reference camera work are probably going to start referencing this Appendix K. The Appendix K is the most onerous thing for all of this because it requires a certain amount of training for these camera operators. It has some interesting definitions. It has just like Method 21 has all the different things. Appendix K has all the same stuff. But one of the main definitions is what they're calling a senior OGI camera operator, the one who's actually able to train other camera operators. You have to have looked at an entirety of 500 sites, at least 20 sites in the last 12 months. That's a lot of sites. And you have to be a senior operator to be able to train other operators. And also the interferences, the weather is obviously going to be a huge interference, and that's going to reduce the number of days. It talks about the equipment and supplies, camera calibration, initial performance verification, and development of operating envelope. Then also you have to do the monitoring survey, how you're going to conduct the monitoring survey. And then the camera operator training is kind of the bigger deal. Field training includes 10 site surveys where the training is observing, the trainee is observing the senior camera operator, and then 40 site surveys where the trainee and the senior camera operator are working together side by side. And then 50 site surveys where the trainee performs the survey, and then the senior operator observes that guy, doing it. So that's a lot of work to get one guy trained up. And then they're gonna have to do a quarterly thing. Now, I can't imagine being a senior operator. You're gonna actually tell your guy you missed a leak. So I'm gonna have to retrain you. And on the retraining side, you have to go back and do about half as much as you did originally. So, I mean, it's gonna be a hard, thing for the senior operator to say, you kind of missed a leak, right? It's probably not gonna happen, too much. So record keeping references, all that's pretty standard, same thing as LDAR requires. But for some simple math, 900 well sites, and including the 300,000 that require quarterly or semi-annual monitoring. One technician can maybe do 10 well sites a day, and there may be 100 days during the year where you can actually do these. So maybe 1,000 well sites per year. What we're going to need as an industry is 1,500 additional experienced camera operators, and we're talking about an industry that maybe has about 4,000 technicians already. So we're going to end up adding, increasing our numbers, and by 30, 40, 50%. And probably on a regular basis, we'll probably increase the number of technicians by 1,000. Not only do we have to increase the number of technicians, we're getting to the end. We're also going to have cameras. And if anybody has ever had $160,000 burning a hole in their pocket, needing to buy cameras, or wanting to buy cameras, you put the order in, and it takes 2 to 3 months because they don't have these sitting on the shelf. They just don't. So they're all built to order. So they're gonna, once this rule gets implemented, if it does, 2023, I think is the target year that we start doing this. They're going to have to cough up 1,000, over 1,000 cameras, and probably over 1,000 new technicians that we're all going to have to train. So it's going to be a huge new piece of the pie, or a huge new pie that we're all going to have to kind of work together and get through. But yeah, I don't know that it's feasible, getting this much of equipment together in that short of a period of time to be able to actually comply with these new rules. I kind of have my doubts on that.
I think one of the key things with is they've never had something like a detailed procedure with the eyes inside closed. Now that they have this out, even if you're not a quad, maybe one day in the near future, training
Yeah, if this promulgates, kind of like what we're expecting it to right now, it'll be the biggest rule to come out since EV. And again, if you have any ideas that you want to get a camera, now would be the time to put your order in. You know, because after this thing kicks off, you're not going to be able to get one. But anyway, that's it.
So it's been a long 4 hours, that's all we have, but if anybody has questions,